you about what problems are associated while you are treating your heritage um, with the PCC, or you can say Portland cement, right? So let's go to the next slide. So here I'm just showing you the comparison between lime versus Portland cement. And in this, Portland cement was, if you see, the first introduced to the construction industry during 19th century by Joseph Asphodin. And if you read through those literature, you will see how things has been used in case of heritage part, and what problems that are associated. And therefore mortar used before that period, you can say 19th century, we treat them as an ancient or historic mortar. So if you see the lime base, you will see it has advantage. It is sustainable, compatible, longevity is there, then reversibility is there. Reversibility is nothing but it break, like if you see CaCO3, it can break into CaO and carbon dioxide, and it and vice versa come back to its original state. So that is a very good property which cement doesn't possess. Whatever formation has formed, it doesn't go back to the original. And we have low mechanical property, high water and vapor permeability, and its color is white. And further, if you go with the cement part, you are aware with the property. I'm not going in that detail of that property. And if you see the figure 2, this is like I have taken from the work from the REZ 2012 and Palmo 2014, right? So next slide, I'm just talking about challenges in historical mortar, which we reviewed in our recent publications, which you can see it is on the right hand side. It is written by us and my PhD scholar, and this is the paper. And in this, if you see the historical mortar, we need to see like there is less availability on standard process. Then restoration history needs to be very carefully seen. Time and cost, data quality, technique limitations, sample size, mechanical property, mortar decay, authenticity, incompatibility, and premature failure. These are the you can say challenges while you are characterizing your historical mortar. So, and that characterization is quite important while you are solving your problem related to the heritage construction. So you can't go to the site directly and you just say that, no, let's take PPC or something. You need to match, like it's similar, like if you want to marry, you need to see a girl or boy with whom your thought or your things are compatible. So similarly, you can treat this structure, and even if you go to the doctor, he see what matches to your like blood group and all. So you match it nicely, and then so similarly you can treat your structure in that way, right? So if we go with this slide, yeah, I have taken this work from Skumar et al. 2011, and he has elaborated quite well the process of restoration work if you want to repair some heritage site. So this paper is very beautifully written. So if you see in this process, what they suggest is the general approach is means you need to see what is the heritage value of that site and how authenticity is there, still exists, like it hasn't been repaired or still the original materials are there, right? And how well the community or the government required to maintain that authenticity, right? Then there is a conceptual requirement which you need to see what type of material you are going to use in terms of like compatibility, reversibility, right? And then you also have to see the functional and performance requirement and its technical requirement. uh, you need to design a mortar, and you need to develop a recipe for this. So I think this is quite interesting article by Skumar et al. In 2011. So if we go with the challenges in design and development of historical mortar, we have reflected in our review paper that these are the four major concerns while we go for such restoration work, and there is a gap in that. So we don't have any defined process, although Realm and other standards, Euro standards gives guideline on various types of test, but you need to pick those tests. So there is nothing like you need to follow such process or steps in order to achieve the materials. So there is a non-generic concepts are there which people have tried for various structure, although we understand that various heritage structures are having different era and different way of construction, but definitely uh, there should be some standard way in order to repair and restore such sites. We also have to look for the functional requirement and its performance of that particular site in order to put our design consideration into in place. So these are the various you can say pillars of challenges in design and development of your historical mortar. Thank you. So I just need to draw a certain conclusion as I'm reaching my time limit of 10 minutes. So the concept of original mortar characterization before restoration on historical monument is a cornerstone in the design and development of historical repair mortar, and that is very important in order to repair and restore. Further, systematic research into design compatibility restoration mortar to avoid repeated restoration mistakes. So we put a lot of money and we repair with the modern material, but what has happened because I told you lime is like irreversible. So once it get water, it take it and it is also porous, so it ventilate it properly that particular wall. So while in your modern material, if you use PPC and all, their porosity is very bleak, and that is what the old material doesn't like it, and they pop it out. Spelling comes into picture, right? So if you repair it, it will last for an year or two, but definitely means there are studies we have reflected that almost if you do repair with PPC, almost more than 40 to 50% site again goes back to the normal position, right? Further, I will also insist altogether change the belief that restoring historical structure require use of easily available material, since it is now nearly impossible to find the same material initially used for the construction. So you can't go for finding the same material, but yes, you do research at your lab and then you try to find it out those material. So I will end this session by saying that preserving the past is not just about safeguarding the building, but about safeguarding the stories, the memories, and the essence of who we are as a civilization. So thank you, and you can contact me on my email ID. It's there, means I will share it with you. And if you have any questions, you can post those questions to me. Thank you. Thank you so much. Have a wonderful conference and knowledgeable exchanging between people you meet. Thank you. Thank you so much.
Okay. Thank you very much, Dr. Kumar Pallav, for sending us your very nice presentation. And I think there is some technical problem. Please wait. Hello. Hello.
Hello.
Hello,
Good
Dr. Nathan.
morning.
How are you? Good morning.
Good morning. How are you?
Yeah, I am good, Nathan. Uh, Wait, there is a technical problem, Nathan. 1 minute, 1 to 2
Okay.
minutes. Okay. Yeah.
Okay.
Okay. So very good morning, everyone. Hmm. This is the second session, second day of our ICISTECH conference, and we have our second keynote speaker, Dr. Anathan Misniat, who is presently working at the Livermore Lawrence National Laboratory, California, USA. LLNL is a very famous laboratory for basic sciences. Dr. Anathan is working on the decay of 23 neon and 6 helium decay using beta neutrino correlation. Basically, these studies are for the physics beyond a standard model. So the details Dr. Nathan will tell about him, and let us start. Dr. Nathan, please take the charge, and audience is yours. Hello. Hello.
Okay, I hear you. Can you upload my slides, please?
Yeah.
Okay. So,
Can you share your screen?
no, I'm disabled.
You are disabled.
I cannot share my screen.
Wait. Allow. Panelist, huh? He is panelist.
Kindly try it, sir.
Ask for a start video. Video इसका allow हो गया. Yeah, no.
Okay. Now let's see. No, I'm still not able to share my screen. So if you
Uh,
can just
there is
upload my
a
slides.
option share screen.
Yeah, no, but I cannot. Post disabled participant screen sharing. So if you can just upload my slides and then I will talk.
Okay.
Kindly check, sir. Kindly check.
Oh, now I see. Wait, just let me. Okay.
You can see participant chat option and screen share option.
Wait. Let me just share screen. Allow Zoom. Wait, I need to allow it. Okay. Okay, no, I need you to share my slide. I'm sorry I cannot do it. So please just, I sent you my slides 5 minutes ago, so you can just upload them and meanwhile I will talk, if possible. Okay, so meanwhile, I will just have a short, brief introduction. I will talk on basic science, and I would like to share with you some innovative research that we had and we are still ongoing. And here I'm going to the side of basic science, basic physics, and as Dr. Vishal already told you, this what we are calling the physics beyond the standard model. So to start with, I will briefly introduce what is the standard model. And here, when I say standard model, I refer to the standard model of the particle physics. Then I will introduce when we are talking about physics beyond the standard model, what do we refer to? And why do we think about physics beyond the standard model? Then I will focus myself into one part of the standard model on which we are focusing. I will also introduce exactly what we are trying to do or what experiments we are trying to analyze. And I will finish with our experimental results. Okay. Do we have it?
Okay, Nathan.
Yeah.
Yeah, I'm going to share your slides. Okay.
Okay, great.
Okay.
Okay.
स्लाइड को ओपन कीजिए
हाँ शेयर पहले स्लाइड ओपन है okay
Okay, great. So now I will start.
फुल स्क्रीन ऑप्शन पे
So okay, next slide. Okay, so I already briefly introduced what I would like to talk about. So we can already go to the next slide and to talk of what is the standard model of the particle physics that we are talking about. Okay. Okay, next slide. Okay, so what is the standard model? The standard model of the particle physics is a framework to understand the world in the fundamental level of the elementary particles. And when I say elementary particles, I mean subatomic, the components, the most elementary components of the nucleus and the particles that we do have in the world. Or we cannot divide them into another particles. The standard model is one of our best frameworks that we do have. So it has great predictions. When we do have experiments to verify its predictions, we are getting amazing results. And yet, this is not good enough. Let's go for the next slide. Okay, so we know about 4 interactions. I will call it this way. Sometimes we are calling them forces. We have the strong interaction. The strong interaction is in charge of the nucleus. So we do have the quarks, what we call, you see them on top, the purple particles. They are the elementary components of the nucleons, the protons and the neutrons that later on are a compound of the nucleus and the nuclei and everything that we do have, and more exotic particles. We do have the electromagnetic interaction that we are all familiar. All the chemistry is the electromagnetic interaction between atoms, and also the fact that atoms are neutral, and the fact that we see is also the photons that mitigate the electromagnetic interaction. Then we do have the weak interaction, which is responsible for the radioactive decay of various elements. And the last one is the gravity. The first 3 interactions are embedded within the standard model framework. And this describes the particles you see here in the table to the right, and also their interaction. How do they interact with each other? And you see the red particles, these are the particles that are the bosons, or particles that carry the interaction between the various particles. Okay, next slide, please. So if it's that great, why do we ask ourselves, what about physics beyond the standard model? So we still have many open questions. What about gravity? The gravity, we know it exists, however, it's not exist within the framework of the standard model. So if you would like to have something that includes that, we need to have some extension to that standard model. Or why do we have much more matter than antimatter? We don't have an answer for that. What about dark matter? And here you can see in the left side, all these blue clouds are hints for dark matter that we know that exist from gravity measurements. And what is about the nature of neutrinos? Okay, next slide, please. So the research for physics beyond the standard model is composed of many groups in many different areas of physics. We have astrophysics, nuclear physics, condensed state physics, and much more. Here I gave just one example of a detector that's called Katrin, which used to measure very high precision the beta decay of different elements. And they can see to the left that in that decay we do have two particles that emitted. One has a mass and one considered within the standard model to be without any mass. However, we have evidences that it do have a very small mass. So the experimenter is trying to focus in the edge of this spectrum. You see the arrow that lead to that spectrum, and to figure out whether we see all kinds of different, very tiny differences that will allow us to measure something. Next slide, please. Another example is direct measurement of particles that not exist within the standard model. One particle name is weakly interacting massive particles, WIMP. So this is example for a different detector, it's called LZ group, and they are trying to look for that. Next slide, please. So after I gave you a brief introduction about the standard model of the particle physics and the physics beyond the standard model, I would like to go into the weak interaction as I introduced before. What is the weak interaction? So as I said, it's about the radioactive decay of particles, and it's very unique because it's breaking symmetry. We have many discoveries in that area, and many open questions are still exist. For example, neutrino physics, do they have mass, oscillations, and are they our own particles? Next slide, please. So, okay, so let's go again for the last slide. I would like just to make explain myself better. If you can go please to the last slide, just for 1 minute. Okay. So what I wanted to say is that we do know two kinds of symmetries. The first kind is kind of perfect symmetry like a mirror. It just reflects what it sees. So this is a perfect symmetry, absolute symmetry. On the other hand, we do have our body, which is our left side and our right side are almost the same, but they are not exactly the same. So this is an approximate symmetry. Now, the weak interaction is just the opposite, is breaking symmetry. However, we do have a question whether it's completely breaking the symmetry or just roughly breaking the symmetry. Why it is so interesting, this question? If it's absolutely breaking the symmetry, we don't have anything new. So what we know about the theory that we do have covers everything. We have nothing to look for. However, if the weak interaction only approximately breaking the symmetry, then we have maybe a new physics that is hidden there, and we need to discover it and have some extension to the standard model. Okay, so in the last slide, I first wanted to show how does the beta decay process looks like, where we do have a nucleus that one of its nucleons, either proton or neutron, is decaying and become just the opposite. So neutron become a proton and a proton become neutron. This involves emission of electron and a neutrino. Now, the theory of the weak interaction was proposed during the late 40s. And very soon after it was proposed, there were all kinds of experiments how to find out exactly the nature. One of the opportunities was to measure the recoil of the recoil that left after the decay. Now it's very hard because the recoil and like the mass of the electron, which is very small, the recoil is very massive. So its kinetic energy is very small. So it's very hard to measure its energy. However, if we look on the spectrum, we can clearly separate the different opportunities that we do have. Now, we found, finally, we do have very good experiments, and one of the best ones was conducted in 1963, and with an uncertainty of 1%, and they found out only one interaction. However, as you see here in that slide, in 2016, a paper was published and said that, oops, the way they were analyzed, the results were a bit incorrect. You see here this graph, you see here the dotted line, which is the way that the results were analyzed all the way back. However, if you see the blue band, this is the way that we need to consider the results. We need to do it a bit differently. Now the question is, what are we able to do? Do we have to throw the old data, the old results, because it was not analyzed correctly, or maybe we can fix it? So in that experiment, we do something very interesting, that we do have the data itself. So we may be able to reanalyze. Please, next slide. Okay, so one thing is that it will help us in future experiments to analyze them. So once we'll have new data, we'll be able to do it. It will improve the previous results, and it will let us better consider the various parameters and constraints. Next slide, please. Next slide, please. Okay, so as you see here, these are going back. So we have the decay. We have the little tiny arrow is the recoil, and the two little yellow balls are the particles that emitted. We do see the angle between them. And we have two parameters. One is refers to the angle between them. This is A. The other one is called B. Next slide, please. So as you see here, in the past, what they used is this equation, and instead we are just generating different spectra. Each one contains only one parameter, only one component of the spectrum of the recoil. And as you see here, to the left, we have the experimental result, and then we are able to simulate the recoil spectrum to give weights to each one of the components and to see whether it fit or not. Next slide, please. So what you see here, instead of using equation and fitting things into equation and having kind of previous assumptions that some of the parameters are equal 0, so on and so forth, we let all the parameters play into the game to see what the models say. And as you see here, first our model succeed to fit to the experimental results. And you see to the right side, the X, which is the standard model prediction. We are very close to that prediction. Next slide, please. So going back to the numbers, so we do have here two parameters, A and B. The standard model predict that A equal -3rd, B equals 0. The first measurement from 63 is very close to -3rd. It's within the uncertainty. Remember, we are doing experimental physics, so we have uncertainties that are coming with the results. And we have an assumption about B that it equals 0. Reanalysis of that data gives results that are a bit different, -0.3308, sorry. But again, it's within the uncertainty, it's very similar. However, the B is still equal 0. And in that work, well, we reanalyze the data, given no constraints about any of the parameters. So all the parameters are free. A is still very similar. However, this is the first time that we do have some number for B. It's also, even though it's not zero, it's still consistent with the standard model. And as you can see, even though our results look a bit worse, we have two results, not only one, and the uncertainties are very similar. Next slide, please. Okay, so I will summarize. First, I had a brief introduction to the standard model and the physics beyond the standard model. Then I showed that measurements of the standard model predictions allow us to determine maybe we do have physics beyond the standard model or not. I focused the weak interaction specifically. Then I show you a reanalysis of all data. This is also to improve the results that we do have. However, another thing that we are able to do is to prepare ourselves for future experiments. Thank you very much. Have a great day. And I would like, of course, to thank all the collaborators that are, you can see them here. Thank you very much.
Thank you very much, Anathan, for a very nice presentation. And audience, these results which have been shown in this conference are very important results to understand the weak interaction. And another one question from the audience side in this physics beyond the standard model is very interesting topic. So someone is asking that is there any possibility of measuring neutrinos mass exactly with some accuracy or somewhere in the world in some lab it is going on?
So one opportunity is what you saw, Catherine. They are trying not to measure directly the neutrino. However, if the neutrino has a mass, when we do have a beta decay, so when a neutron becomes an electron and antineutrino, you need to, some of the energy of this decay need to go to generate this mass, okay, following the equation that we introduced by Einstein, E equal mc squared. If so, then the end point of the decay curve, so we have very few electrons with that energy, it will look a bit different. So it will, how to say it will move a bit toward lower energies instead of the total energy of the decay. So this is one way to measure it, but again, it needs to be very precise measurement because the differences are very small. 1 eV, which is very hard to measure in nuclear physics detectors. This is a resolution, I don't know, outstanding resolution. You also can tell them that we are talking about KeV, thousands of EVs. So this is one opportunity how to measure these particles. They're also direct measurement, but I'm not sure if they are trying to measure their mass as well, or only just to see neutrinos.
Okay. Okay. So thank you very much, Nathan, Dr. Nathan. I think audience, if someone has some query to ask, please ask. I think no more question, Nathan. So
okay.
Thank you very much.
Okay. Have a great day. Thank you very much.
Thank you, Nathan. Now I would like to invite Dr. Deepak to take the charge of the session. Please.
Thank you, Dr. Vishal. So now we are just heading towards the other agenda of this track. So we have one more keynote speaker, Dr. Narsingh Jha, who is assistant professor in Department of Applied Mechanics, IIT Delhi, but he's engaged somewhere. So we will be blessed by his words afterwards. So I'm just starting the session, and I'm inviting the first paper, that is paper ID D04, which is having title Design and Development of Microhole Grinding System of Zirconia Ceramics for Quality and Productive Improvement. So if Dr. Liu, if you are available. Okay, so I am just starting her video presentation. Okay, and afterwards, I hope she will be joining us to just answer your queries. So I'm just starting the video presentation. Actually, there was some technical glitch, so I'm again starting the presentation.
My research is about design and development of micro-hole grinding system of the color ceramics. My name is Liu Hongjuan. I work in Ningbo Polytechnic in China and study in University Kuala Lumpur for a PhD. I will introduce my research in following 6 parts. In recent years, the demand for ceramic ferrules in China increases rapidly, and the material, the color ceramics, has excellent stability in extreme working environments such as high temperature, precision, and high wear resistance, making it the preferred material for optical fiber connectors. However, the color ceramics are hard, brittle materials with high hardness, fragility, low fracture toughness, and poor machining ability. The size of the precision microhole is about diameter 0.125 mm, and the tolerance requirement is 0.001 mm. So it's very difficult to machine the microhole. To solve the problem, we designed the model of the microhole grinding system. We use conical steel wire to grind the ferrules fixed in the fixture, and the fixture is sealed in the rotating spindle. During the grinding process, it was found that the difficulty lies in the adjustment of the wire tension. So we improved the system. We add 2 sensors, 3 photoelectric switch, 4 counterweight system, 10 spin block switch, and 11 buffer in the system. To reduce the impact force during the steel wire tension process, buffer and spin block switch was set near the wire winding handwheel. For the problem that steel wire tension is difficult to adjust, a counterweight system was installed to adjust the steel wire tension, and a photoelectric switch was installed to detect the position of the counterweight system and send a signal to the servo motor to realize the positive and negative rotating of the steel wire. And in order to avoid the spindle from idling due to sudden breakage of the steel wire, a sensor was set. After optimizing the design, a prototype was developed and put into trial production. It was tested for 1 month, and this is the comparison before and after the optimization. These are the conclusions. The design of the grinding system solves the problem of difficult processing of the color ceramic material. And the optimized design of tension adjustment greatly reduces the frequency of steel wire replacement. The improved system has increased the production, and the product qualification rate has reached over 90%. Also, this design provides a reference for future process of hard and brittle materials. That's my presentation. Thank you for your listening.
Thank you, Dr. Liu, for this wonderful presentation. So if anyone has any query, we can address that. Otherwise, we will move to the next keynote speaker, Dr. Narsingh Jha. Sir, if you can unmute yourself. Dr. Narsingh Jha.
Hello,
Hello, good morning, sir.
good morning. How are you?
I'm fine, sir. So I'm just giving you the dice, but before that, I want to introduce Dr. Narsingh Jha, who is assistant professor in the Department of Applied Mechanics. And before that, he's completed his doctoral degree, that is PhD from ISC Bangalore, India. And he has so many experience in abroad as well. He did his postdoc from University of Cambridge, UK, and worked on environmental fluid dynamics. And he has also worked in Weizmann Institute of Science, Israel, and also worked in. Right now, he is working on behavior of turbulence flow. So, Dr. Narsingh Jha, sir, please, you can now talk about your research and everything.
Yeah. Can you see my screen? And
Yeah,
is
yeah,
it
sir. Yeah, sir.
is it in full
It
screen
is.
mode?
It is not in full screen mode.
Okay,
Yes, now it is on full screen mode, sir.
it is on full screen mode. That's fine. So, can you see my front slide? Is it in full screen mode now?
Yeah, sir. Yeah, sir.
Perfect. Thank you. And thanks for the invitation, Professor Vishal. And it's always a pleasure meeting you and talking to you about different aspects of the research problem which I'm working on. So today I'm going to talk about elastic instability in plane Poiseuille flow. And before I talk details about it, what I would like to emphasize is, most of our flow. So if you face water or air, they are technically in fluid mechanics term, they are not called elastic because their elastic property is negligibly small. Okay. But that's the water outside. But if I look the fluid inside, okay, so my blood is elastic, and when you sneeze, our cough and our mucus is elastic, and lot of other kind of flows which you find in nature are having elastic properties. Say, flow of cornstarch and those kind of things. Okay, and some other place where you see elastic flow is, say, it has been used extensively for drag reduction in pipelines. So some of you who have heard about Alaskan pipelines, which is a very large pipeline for crude oil transfer, there the flow has been purposefully made elastic to reduce the drag. And with those motivations, as they are found in nature, and most of the cases, places there are turbulence in nature. So we need to understand what is the mechanism by which they become turbulent. And today I'm going to talk about that. Okay. So the outline of my talk is going to be, first, as I have motivated the problem already, I'm going to talk about introduction and some relevant studies, such that I place you first where broadly we are going to take this problem today. And once that place is, once it's placed where I'm going to place it, then I'm going to talk about the details of the work. And I'm going to talk about elastic instability, and I'm going to talk about different structures and waves which is found in elastic instability. And I will further show you some of the non-intuitive mechanisms which we found in these kind of flows. Like, one would typically not expect that you can have Kelvin-Helmholtz instability over here. And there were intuition, and in the process we'll also tell you there are many long-standing intuitions that we broke in the process of working on these research problems. And once I explain you those things, the details of the research, then I'm going to conclude my piece of work. And so first, again, to have the motivation in slightly detailed and systematic manner. So technically, in fluid dynamics, the most relevant or most talked about non-dimensional number is Reynolds number, which most of you must have heard about. And Reynolds number has two aspects. The first, it's the ratio of inertial force to viscous force. That's the definition side of it. And the other side of it, this is the non-dimensional number, which decides that when flow is going to stay laminar and when it's going to become turbulent. Okay, and when Reynolds number is very large, that means flow has inertia also. And that place I was telling you that a lot of practical application you find at either it be in elastical pipelines or it be in the pipelines of the fire jet, where typically it's been added to increase the flow rate for extinguishing fire, or sneeze. These are the places where it's high Reynolds number and flow is elastic. And at those places, there are two important parameters that, if you add polymer, you reduce the drag, means you save the energy. Okay, and sometimes to understand the fundamental mechanism, it helps you in addressing many of the other kind of problems that we saw during the time of COVID. There were, we literally needed to understand that once we cough, once we sneeze, how these mucus behaves, because they might be a carrier of virus. Okay, that's for high Reynolds number flows. And then there is Reynolds number very much smaller than 1. And as I told you, Reynolds number is the ratio of inertia by viscosity. And if that ratio is much less than 1, means inertia is negligibly small. And if inertia is negligibly small, means your flow doesn't have inertial stress. And then only stress what you have is elastic stress. And that's the key. What we do is first we do experiment at small Reynolds number, where inertia is not there. We understand the dynamics of elastic stress. And once we understand the dynamics of elastic stress, then we extend it to elastic plus inertial stress, that is high Reynolds number. And that's where we have a lot of practical applications. And knowing the first part, inertia-less flow, will help us in understanding inertial flow much better, as we'll see as we progress in time. And obviously, a lot of practical application of this is there. It's typically used in oil extraction, in oil rigs, okay, and groundwater remediation. It's as its Reynolds number is very small, which is typically the case in microfluidics. It's typically is used in microfluidics for mixing, and a lot of our blood flow typically Reynolds number is small, and small veins. And some of these elastic flow will help us in understanding some dynamics there too. Okay, so now that motivation, I have motivated the problem. Now I'm going to talk about the fundamental piece which you need to understand to appreciate the problem better. So I'm going to introduce the fundamental nature of the problem. Okay, so what you have technically, as it's elastic flow, I'm going to talk about, and I'm going to talk about elastic flow instability. So that basically means that you have something which is going to create elasticity, and you have a flow over there. Say if you have a flow like this, okay, you have a flow velocity, and which has a gradient in y direction, and it's moving in x direction, and you have some coiled polymer here. Okay, so typically the natural state of polymer is going to be that it's going to stay in coiled state. Okay, but the moment you put in some stress here, that means you can stretch these coils, and they are going to be stretched. And the moment they are going to be stretched, there are two things which is going to happen. First, it's going to store some energy now, because typically, if you have to stretch something, you need to add some elastic energy to it. That means, and so it's stretched, it got some energy, and it's going to create an elastic stress field. That's from the elasticity side. From the flow side, these polymers now extracted some energy from the flow. Okay, so these are the basic things which are happening in the two-way manner. Okay, but here we are looking at two separately, but one would expect that it's not just a stretch. If there is some instability mechanism which is going to trigger, then they are going to interact with each other, and this is going to be a two-way coupled problem, and that's what we are going to look at today. Okay, and with these, as it's going to store some energy, your viscosity of the flow is going to change, because you are going to have some viscosity because of polymer also. And these stress field, or these polymers, now they are going to interact with either the waves in the flow or vertical structure into the flow if the flow is turbulent. And if the flow is transitional, then you have waves there. And in the process of all these two-way coupled interaction, what in turn is going to have is your drag, your momentum, and your energy transfer might be affected because of these two-way coupled interaction. Just to show, have you a sense that, if you add a lot of polymer in the flow, it becomes this thick, but this is not the regime where we typically operate. This is just to show you that how typical, polymer laden flow would look like. We have much lesser concentration typically into the flow, or because that's what you find in a lot of practical applications. And if you look at individual polymers in time, and if I just superimpose to see the dynamics of these polymers, how do they behave in time? Okay, and now with those motivations and fundamental introduction, what we are going to have today is what I'm going to have is, yes, so one important thing which I need to state is I'm an experimentalist. So what I'm going to present today is, you will see that most of it is experiments with some applied maths kind of thing to look at energy transfer and those kind of things. So the big chunk of the today's discussion is going to be the experiments which has been conducted for these kind of flows to understand the fundamental mechanism and physics of the problem. Okay, so typically you have a channel flow where if flow is laminar, your profile is going to be parabolic, and incoming fluid is elastic fluid. Okay, and this is a straight channel, so there is no curve over here. Okay, with this flow setup, what we are going to address is the following. The first thing is that in curved streamlines, it is well known that curved streamlines are linearly unstable. So if you find some instability there, that's fine, but they are already predicted that they are linearly unstable. So you expect them to go through some instability mechanisms. But what I'm trying to study here, so this is your curved streamline, but what I'm trying to study here is a straight channel. And in case of a straight channel, your past theoretical understanding says that flow is linearly stable. So one would not expect the linear mechanism to kick in. That basically means that if any transition is happening, that is not through a linear route. Okay, so if the transition is not through linear route, what is the route to transition to elastic turbulence? And most of the talk present thing which I'm going to talk about is Reynolds much less than 1. So we are only going to look at elastic instability, and towards the end I'll tell you the ongoing work where we add in the inertia also. Okay. And so what is the transition mechanism to elastic turbulence that we are going to look at? And parallelly, we are going to look at that once if it transitions, what is the scenarios or parametric conditions at which it transitions, and what is the mechanism of transition, what happens to coherent structures there, what is the coupling between flow stress and elastic stress and flow and elastic stress. Okay, and then we'll relate this purely elastic transition to turbulent drag reduction where you have inertia also. Okay, so some fundamental governing equation and some fundamental parameter in elastic flow. First is the Weissenberg number. As I was telling you, the Reynolds number is the non-dimensional ratio of inertia to viscosity. Your Weissenberg number is the non-dimensional Reynolds number, which is the ratio of elastic relaxation time, or time scale related to elastic properties of the flow divided by the flow time scale. Okay, so L is your flow length scale, U is your flow velocity. If you divide these two, you get flow time scale. So this is elastic time scale divided by flow time scale. If this is much less than 1, means elastic time scale is much less than 1, that means that any flow change, if you do elastic, is going to respond to it much faster. If that's so, then your flow is going to behave like that there was no elastic fluid added to it. There was no elastic properties added to it. So it behaves just like Newtonian flow. But if your elastic time scale is either similar to flow time scale, means if you do any change in this, you are going to see a change in that at same order. Or if your elastic time scale is much larger than flow time scale, so that if there is anything happening in flow, it's your elastic thing is going to take much longer time to respond to, is going to take much longer time to respond to it. Means any perturbation, if it's added, it's going to stay there and your elastic thing is not going to decay down. And those non-dimensional parameter regime, the governing equation that you have is the typical your acceleration term, that is unsteady acceleration and convective acceleration, which is balanced by your pressure force and your stress force. But now your stress force has two components. One is your solvent stress, another is your polymer stress because you have polymer in the flow. And solvent stress is the typical way what we write in classical Navier-Stokes. But your polymer stress, you have a separate governing equation for that. That's your polymer stress and its derivative, because its derivative is again equal to your polymer viscosity multiplied by velocity gradient x. Okay, so that's there. Now what we can realize that this is again FNAP model. So that's like finitely extensible nonlinear elastic model. And what I'm going to tell you now again, one thing which you have to keep in mind, that's that this is again a model to model the polymer stress. Okay, this is just a model, one of the many model which is present, and every model has their own strength and weakness to handle it. But you have to realize that if you have these things apart from this, so you had first nonlinearity in the flow because of the nonlinear term over here. Because of this, now you have another nonlinearity in your flow. Okay, and so now you have earlier in typical Navier-Stokes, you had only one governing equation, which was nonlinear. Now you have two governing equations which are nonlinear, and solving it mathematically is non-trivial. Okay, and till date we don't have any solution for it. And again, for this elastic stress itself, there is no foolproof theory till now. Okay, that in having all these circumstances, experiments help you in understanding physics if one can do a very careful experiments to look into the fundamental nature of the problem. Okay, so now let's split the problem further. Okay, and look at some of the previous studies. So this is again studies from my postdoc group where I worked on this problem, that they looked at curvilinear streamline. So over here, streamline is curved because it's circular. Oh, it's like Taylor-Court flow. And there we know that if the curved streamlines are curved, then you have your flow is already linearly unstable. So you get your turbulent behavior, elastic turbulence over here, which has been shown 20 years back. Okay, and the exponent typically what you get in the spectra is -3. That's the typical marker of elastic turbulence. Okay, and if you look at previous study for 2D channel flow, like a straight streamline, which is the focus of the present study, previously it had been marked that just Newtonian channel flow, the linear instability occurs at 5772, Reynolds number of 5772. But in experiments, it has been found that the transition what you observe in experiment is not at 5772. What typically you find is only from typically from 1200 to 2000. That basically means that if it would have been above 5772, that means that linear instability has kicked in. But your instability happens of the order of 1000, 2000. In that case, you know that linear instability has not kicked in because flow is linearly stable yet. And if still you find turbulence, that basically means that there is some nonlinear mechanism which has kicked in for flow to make turbulent. And those nonlinear mechanisms, it has been shown by other researchers, is either subcritical or non-modal, depends on the flow. Okay, but something which is present over here is that once you have these kind of instabilities, what you find is you find a streamwise vortex. Okay, and you have a traveling wave. Okay, so traveling wave and streamwise vortex is the marker what you find in flow to understand that flow is going through instability. Okay, and other thing in terms of a structure, what you find is you find streamwise rolls, streamwise streaks, TS waves. That's called Tolman's resting wave because these are the researchers who found out these waves. And once it goes through this instability, at the end of this instability, once flow starts becoming turbulent, what typically you find is hairpin vortex. Okay, that's for Newtonian part. For elastic part, in 1969, Lumley and 86, Degens, they looked at elasto-inertial instability or turbulent drag reduction or elasto-inertial turbulence, where Reynolds number is much, much greater than 1. And they observed the drag reduction and they related it to the drag reduction over here. What we found the state corresponding to that is a modified Newtonian state. But there have been now recent studies which argue and try to prove that the state in turbulent drag reduction, what you find is not a modified Newtonian state. It's altogether different state which is governed by elastic properties of the fluid. And if it's not related to Newtonian part, if it's completely driven by elastic part, then it's a structure and some of the properties may be similar to what we find in elastic turbulence. That's what when I was starting my talk, I was relating it to, that if we understand elastic turbulence better, we can understand turbulent drag reduction at much higher Reynolds number also relatively better. Okay, and if we look at straight streamlines, okay, there are two kind of nonlinear instability what can kick in over here. One is subcritical instability, another is non-modal instability. Okay, so subcritical instability, which has been looked at by Aratia and others, and even by Morozov in 2005, what they observed is first they find this, like long structures in y direction. If you look at its evolution with time, and they fluctuate. Okay, so this is what you observe when you look at fluctuating velocity. But if you look at RMS and its evolution with Weisenberg, which I was telling you that this Reynolds number is much less than 1, this becomes an important number. In that case, as you increase Weisenberg, your RMS increases. And once you come back, your RMS comes on a different path. That basically means that your flow has a hysteresis, which is a marker of subcritical instability. So one important marker of subcritical instability is your hysteresis and the flow property, in the evolution of flow properties. But what we need to understand that this study done by Aratia and others, your streamlines are not perfectly straight because it's a square channel. So you can have curvilinear this because of your span-wise gradients. Okay. And they do not comment on a lot of structures, how the structure look like, because structure is another marker for subcritical instability. So what we looked at in the present study is the complete mechanism of all this. Okay, and you also see that the Weisenberg, which typically go is of the order of 10 only. So it will be better. It would be good to look at what happens at higher Weisenberg and how does it evolve in a much better manner. And also what is the resolution of these things is important thing to look at. Okay, other way to look at these things is your non-modal or transient growth instability. Non-modal or transient growth instability basically means that because of non-modal evolution of your perturbations, they grow to some amplitude. Okay, and after that your non-linear mechanism kicks in and your flow becomes turbulent through this non-modal growth of the perturbation. Okay, that basically means that your linear non-modal amplification takes it to finite amplitude, and at those finite amplitude, it triggers non-linear flow states, which causes a transition to elastic turbulence. And there have been some analytical work to look at some of these things. And the one thing what they observe over here is you have a strong span-wise forcing over here. Okay. So now we discuss about our experiments and how do we want to address this problem further. So as we want to look at instability, that basically means that you don't want to add any perturbation, or your external perturbation shouldn't impose on the systems. You should have a controlled perturbation in your system. For that, what you don't want to drive it through pump or anything. You want to drive it through pressure so that there is no external perturbation added to the system. And all these things you want to keep it on an optical bench such that there is no perturbation from the ground which is imparted to the channel. So everything is driven by a pressure, nitrogen cylinder and pressure system, where pressure is regulated in a very controlled manner for having a good control parameter, for a good control over your parameter range, and everything is kept on an optical table so that you don't have any uncontrolled perturbation added to your system. Okay, and what we do is we add some controlled perturbation. So we add a lot of cylinders in the flow line, and through those cylinders, the flow passes in, which adds the perturbation to the flow, and we look at the evolution of these perturbations in case of straight streamlines, which is 2D channel flow. So the height of the channel is 500 micron and width of the channel is 3.5 mm. That means aspect ratio is 7, which has been shown in the previous literature that aspect ratio of 7 and higher, your flow at the central part remains 2D, and we are going to look at instability at those parts. And from the measurement side, we have time resolved micro PIV. So we have good resolution in time and good resolution in space, through which we look at the flow properties. And a lot of things over here again was built in house because we did not have micro PIV inbuilt from supplier. Okay, and this is how our setup looks like. So, and again, you need to see the evolution of your perturbation with space also. So everything is kept on a motorized stage where we move the stage once we are doing experiments to see the evolution of the perturbation in space. And typically kind of measurements, what we do is first we do integral measurement like pressure drop and pressure fluctuations. Apart from that, we also do some velocity measurements and structure measurements. And what we try to, the question which we try to address is that, when we don't have any curvilinear streamlines and flow is expected to be linearly stable, can we have the transition to elastic turbulence? If so, what are different structures? And we have good resolution in time also. We can go from 50 Hertz to 3200 Hertz. And the kind of temporal scale, what you expect is of order of 100 Hertz. So we have good enough resolution to resolve anything, any flow time scale which is present in the flow. Okay, so as we have a cylinder, we know that, and these flow parameter conditions and the flow behind cylinder adds some vorticity to the flow. That we first check that our perturbation is sufficient to create, our cylinder perturbation is sufficient to create the perturbation in the flow, because Reynolds number is much less than 1, that we should keep in mind. Okay, so we have multiple cylinders over here through which flow goes, and first we look at pressure drop across this. And you see that there is a clear transition here in your friction factor with Weisenberg, that you are adding the perturbation to the system. That is clear. That is clear in the mean pressure drop, and it's clear in terms of RMS that yes, you are adding. Your perturbation is typically of the order of 25% of the mean. That's behind the cylinder which you add to the flow. That's not the perturbation, for which we are going to look at the growth. If this perturbation which is being created behind the cylinder, if this is added to the straight streamlines, what happened to that we are interested in? Because at this point you will have curvilinear streamline, and the transition mechanism over here is very different from the transition mechanism which one would expect far downstream when your flow lines are linear, when your flow lines are straight. Okay, so now again, this was collaborative work. As I told you, this is the work of my postdoc. So my postdoc supervisor, Professor Victor Steinberg, and I worked together on this problem. So we know that behind the cylinders, you have fluctuations in velocity, you have a lot of structures, you have a spectra, which is typically minus 0.17 behind the cylinder. And you have increased pressure drop across the cylinder. That means you are adding a strong enough perturbation behind the cylinder, and that is marked from here. And if that's so, let's look at what happens far downstream where flow lines are straight. Okay, so once your streamline are straight, if you look at far downstream from here, okay, so let's see what happens at this point. Okay, and this is L by H is 26 by 82. If you look at L by D, this typically becomes 130. And it has been shown in the past that by this, anyway, your perturbation added by the cylinder, cannot exist in a strong manner over here. Okay, so let's look at what happens at L by H 26 by 82. So again, if you look at your pressure drop, it's almost close to 1, and then suddenly it increases by 30%, and so this is your elastic instability part, and then is your elastic turbulence. And after certain Weisenberg of the order of 250, you have drag reduction. That's for L by H 26 to 82. And if you look at far downstream, again at that point L by H say 200, 250, your pressure drop or your friction factor is almost equal to the friction factor of solvent or friction factor for laminar, because all this is around 1 with some fluctuations, which is the experimental noise. But if you look over here, you see there is strong fluctuation in the span-wise velocity, and there is strong fluctuation in RMS of differential pressure, and all this also triggers in sync with the trigger in the mean quantity like CF. So mean quantity or span-wise velocity and span-wise pressure and stream-wise velocity fluctuation. All of these has trigger, and all these trigger at similar Weisenberg tells you that there is trigger instability in mean and integral properties. So your RMS, you have increased friction because of instability, you have fluctuating flow, and your RMS increases with increasing Weisenberg. These are the marker for elastic instability for straight streamlines in 2D channel flow. So now those we looked at either properties at a point or integral properties. Let's look at spatiotemporal properties. Okay, so in this, once we move down, your time is increasing, and you look at space, you look at L by H and Z by W, and you look at fluctuating velocity, fluctuating vorticity, and fluctuating span-wise velocity gradient, dou W prime by dou Z. And obviously everything is non-dimensionalized. And if you look for all of these things in non-dimensionalized manner, you see that you have fluctuating velocity. That's like you have positive and negative velocity like this in the fluctuating in the mean frame of reference, and one is going forward and another is going backward, and because of that you have Kelvin-Helmholtz instability over here, and that kicks in. You see the instability at an interface, and slowly this instability breaks down and makes the flow chaotic. Same thing you observe in the fluctuating vorticity, and later we'll talk that dou W prime by dou Z is a marker of your streamwise vortex. Okay, so this shows the presence of streamwise vortex and streamwise streak, which is the marker of non-modal instability into the flow. Okay, and you see that this is a cyclic process because your flow is there is some interface over here of positive and negative velocity, and this interface slowly evolves with time and they break down with time. And we'll look at the breakdown of these scales in our flow. And the Weisenberg number for this case is 185, which corresponds to elastic turbulence case over here. Okay. So let's look at some of the structures, all these three, what we saw over there. Let's look at that. Okay. So this is your fluctuating velocity field for Weisenberg 185, where this corresponds to elastic turbulence, this corresponds to elastic instability, and this corresponds to drag reduction case in CFRE plot. Okay, and you see that there is inherent presence of streaks in all the cases, but the complete breakdown of a streak and presence of streamwise vortex is more dominant in case of elastic turbulence, whereas you don't see that organized breakdown of a streak for elastic instability and drag reduction case.
Dr. Narsingh,
Yes.
Can you please be fast because we are
running. I'm going to wrap up.
Yeah, please.
Yeah, next few slides on. So you see in fluctuating velocity field, but it's a bit different from the previous thing what we found in literature for a square channel. Okay, because now you don't see the full span-wise structure, but what you found in the literature. We have more broken down structures, and we look at the complete cycle, which was not possible to see in previous studies. Okay, and with this, once you look at velocity spectra, you also see the waves and presence of elastic wave over here, and one can characterize the presence of elastic wave. So now what we saw three things. We saw elastic waves, we saw streamwise structures, we saw streamwise structures like streak and streamwise vortex, and all these three interacts, and they cause the broken down structures or instability, non-modal instability, which causes the elastic turbulence. and this was the takeaway for it. This work has been published in PNAS and other vision archive, which we have been, for which we are preparing the rebuttal for its publication. Thank you very much. Thanks for your time and attention. Vishal, I'm done. Vishal, are you there?
Yes. I am here.
Yeah.
Are you over?
Yeah, I'm done. Any questions from the audience?
Yeah. There is one question from audience. This is very curious question actually. Is this turbulent flow is your results basically validate the for non-smooth surfaces also? Is non if the surface is non-uniform, then these results will.
Currently what we did is for smooth surfaces where surface is completely smooth, but the dynamics would change once there are non-smooth surface, because now we have one extra length scale into the problem that will be coming from the perturbations added by the surface. Okay.
Yes.
So
Because dragging of turbulence is also a big problem to deal with.
yeah, so it depends. So if you want turbulence, then you can add that, but if you want to inhibit turbulence, then it's better not to do that. Again, it also depends on the parameter range in terms of Reynolds number and Weisenberg, because we saw over here that it has dual influence. So elastic first it triggered the instability, but then later it also brings in the drag reduction, so it suppresses the turbulence also. So this is the dual nature of elastic stress in this kind of flow, that first it triggers the instability and then it suppresses the instability too. So it depends that in which control parameter range you are, based on which you have to see that will it trigger or will it inhibit.
Okay, thank you. So audience, is there any query? So I think there is no more query from audience. So thank you very much, Dr.
Thank you,
Narsingh,
Vishal. As always, it's pleasure
giving
meeting
us
you.
your time. Thank you.
Nice to meet you.
Thank
Have a
you.
good day and thanks for the invitation.
Yes, same to you.
It's my
Thank
pleasure
you.
interacting with the students.
Thank you.
Thank you.
Thank you, Dr. Narsingh.
Thank you.
Okay, so now I am just inviting the second paper, that is D33, which is from Rohit Raj, Dr. Brahmadev Yadav, and Sumit Kumar. So we have the recorded PPT. So I'm just playing that.
Good morning, everyone. I am Rohit Raj. Here, our research on marble powder for soil stabilization. In this brief journey, we will explore how waste marble powder can significantly enhance soil stability, particularly in soil rich in clay. Introduction. In introduction, we derive about soil stabilization. Soil stabilization is the process of increasing the strength, bearing capacity, and overall performance of the soil by the use of controlled compaction and addition of suitable admixture etc. Method of soil stabilization. At first, mechanical method. In this method, the strength, bearing capacity, and overall performance of soil can be increased without addition of any admixture. Chemical method. In this method, the strength, bearing capacity, and overall performance of soil can be increased by addition of suitable admixture as like lime, stone dust, fly ash, marble powder, cement kiln dust, bitumen, etc. Objective. Our main objective were to understand the impact of waste marble powder on clay soil stability and identify the optimal percentage dosage of effective soil stabilization. What motivated us? Well, it's the dual advantage of economic and environmental benefit through the recycling of waste material. Building on soft clay soil has always been challenging due to their low shear strength. Previous research has explored various soil stabilization methods, but today we are focusing on marble powder as a potential solution. It is a byproduct of marble cutting, often disposal of without much thought. Methodology. We conduct a series of tests including particle size analysis, Atterberg limit, compaction, CVR, UCS, and soiling test. Result and discussion. Let's dive into the result. The particle size analysis revealed that soil is classified as intermediate compressible clay. Further, after being mixed with marble dust, it was classified low compressible clay. Atterberg limit shows that as marble powder increases, plasticity reduces. In the standard protector compaction test, I observed that MD value increases and OMC decreases as the amount of marble powder increases. Summing of our key finding, changing in plasticity on compaction along with maximum CBR value and UCS of 175.49% and 339 kilonewton per meter square respectively at 5% mix of marble powder. Overall, it was observed that 5% replacement of clay soil with marble powder can be considered as good improvement technique for reducing the cost of project. Conclusion. In conclusion, our exploration into marble powder for soil stabilization has promising implication for the construction industry, offering a sustainable solution and potentially reduce project cost. Thank you.
Thank you, Sumit, for this presentation. So, Sumit, are you there?
Yes, sir.
Okay, so thank you so much for this presentation and your participation in this international conference. In the audience, if any queries are there, okay. So, Sumit, we don't have any query. Thank you so much for your presentation. Uh, Now I am taking privilege to announce or just introduce one more session chair of this session, Ahmed Yusuf Juhadi sir. Sir, if you are available, Juhadi sir. Yeah. So a very good morning, sir. Actually, it is good afternoon in India, as I think also in Indonesia it is good afternoon. I want to introduce Dr. Juhadi. So he is currently assist. Yeah, he's currently associate professor in ITS Surabaya, Indonesia, in the Department of Civil Infrastructure Engineering. So thank you so much, sir, for in just accepting our invitation. And please be with us and just evaluate our session. Sir, please bless with us with some your words. Sir, if you are there, yeah.
Hello. Hello.
Hello, yes, sir. You are audible, sir.
Okay. Okay. My name is Ahmad Yusuf Zufri. I'm from ITS Surabaya, Indonesia. I presented my paper yesterday with my junior lecturer, Rahman Haryanto. Yeah. I'm from civil engineering. Yeah. Which focus on hydro civil engineering, transportation in civil engineering, and building civil engineering. So if you want to discuss or make webinar or something with my institution, please connect to my address, my email address, yuf_ci@yahoo.com. Or you can ask the host the detail of my address. So we will contact and then we will create coordination about my institution. Please let me know and then we create coordination about us. Thank you for introduction.
Thank you so much, sir. Thank you so much for accepting our invitation. So please be with
Okay.
us in this session and please evaluate our speakers. Thank you, sir. Thank you so much.
Okay. Thank you. You're welcome.
So now I am inviting the other next paper, that is D38 by Dr. Umesh Kumar. Hello.
Hello, good afternoon all. Today I'm going to present my topic, that is the efficiency removal of methyl blue dye from the aqueous solutions through adsorption methods onto natural banana leaf absorbents. And the following authors who contribute their valuable thought in that research paper. So that is the outline of presentations, introductions, research objective, materials and methods, result and discussion, conclusion and reference. So water pollution is the main concern about our sustainable life. As we know that 70% water available in our earth, out of 70, 97% water, that is the salty water, 2% that is ice cap, and only 1% that is the fresh water. So the fresh water is the limited resources, and it will be continuously decreasing in the upcoming decade. So the continuous regular decrease of the freshwater resources resulting from increasing in population density, deforestations, coal mining activities, and climate change. And dye are the present in the influence coming from the various industry, such as the dye and its manufacturing, textile, painting, plastic, leather, and pharmaceuticals. Among all the dyes, methyl blue is used in the largest scale from the different industries. Methyl blue is toxic dye, and its exposure to the human cause several health risks, uh, such as nausea, eye injuries, and vomitings. So, due to the its ecotoxicities, researchers have been looking for its mitigations by the adsorption process. That is the research objective. First, selection of bioabsorbents and absorbents, then categorize study of absorbent and adsorbents, batch mode absorptions, and absorption kinetic methods. Next, that is the materials and methods. So we have taken banana leaf from the local market of the Patna, Bihar, and methyl blue dyes that is taken from German Merck companies. So first we have prepared a banana leaf as absorbents. So the leaf were collected and carefully cut into the small pieces. To eliminate any dust particles, they have thoroughly washed with the distilled water and soaked from 2 to 3 minutes. Then the banana leaf were dry in the hot air ovens at 130 degrees C for the period of 24 hours. So once dry, the leaf were processed into the fine powdering using the domestic blenders. And the resulting powder was then sieved to obtain particles with the size of 150 micrometers. So it is important to note that this is the natural absorbents was prepared without the use of any chemical additives in the powder making process. So this method shows the environmentally friendly approach to absorbent productions. So next is the batch absorption studies. That is very important. So for that, we have taken 100 ml flask and 50 ml methyl blue solutions of various concentration 25, 50, 17, 100 ppms. We had prepared and different dose of the absorption are added. Then that flask is placed into the automatic shakers, maintain temperature 300 degrees C, agitation at 150 RPMs, and held at constant time and pH. Then the sample filtered to separate the absorbents from the methyl blue solutions. Okay. So finally, the residual concentrations of methyl blue are determined using the UV visual spectrophotometers, and its maximum absorption path length is 663 nanometers. That same experiment, that same batch absorption studies are applicable for the all the equilibrium times, optimum absorption dose, and pH levels. Now, adsorption isotherms. In this contains three key methods for predictions and absorption capacity of the particular materials stand like Friendly's isotherms, Legmar isotherms, and Temkin isotherms. Now, the result and discussions portions. For finding the result, we have go for the same analysis. So the initial same images before the methyl blue absorptions, the image reveals as a surface characterized by the lumping and porous textures, indicating of numerous pores that can be facilitated absorptions. And in the post absorptions, same image, the banana leaf surface appear notable rough, featuring craters like pores that have visible expandants. So these large pore are attributed to the absorption process, which lead to the pore thickening that was successfully inhibited by the presence of the methyl blue dyes. So Next, that is the batch observation studies of the banana leaf. For that, we have take the effects of the contact times. So here I have taken 10 to 120 minutes, and same batch observation process are applied. So finally, I have got 93.58% removal of methyl blue dyes at the 50 minutes with the initial MB concentrations of 25 ppms. Next, that is absorption dose. So here I have taken 0.2 gram to 2 grams. Same process are applied, and finally I got 83.6% with the 1 gram dose. Then pH variation 2 to 12, and same batch adjustment process. And then finally, I got 95.51%, and it was achieved at pH 8. Okay. So next, that is the absorption characteristics of banana leaves to determine that absorption capacity of banana leaf for the removal of methyl blue dye for the aqueous water solutions. Three different isotherms are taken, like Legumar isotherm, Fenris isotherm, and Temkin isotherms. Lastly, the conclusions and outcomes. So by adjusting key parameters such as pH, contact time, adjustment dose, it is feasible to achieve optimum methyl blue pollutants removal in the wastewaters through the utilization of the batch adjustment approach within the natural treatment systems. So finally, when applying the banana leaves as absorbents, a remarkable 83.6% removal of methyl dye was achieved under the condition of pH 8 at 50 minutes contact times, and rotation period is 150 rpm and temperature 300 K, and 1 gram absorption in 50 ml methyl butadiene solutions with the initial concentrations of 25 ppms. So equilibrium data were found to conform closely to the Legumar isotherm equations, and it indicates monolayer absorption of methyl blues. And Temkin isotherms parameters were also determined, and its positive values which suggests as exothermic absorption process. So in conclusion, the absorption isotherms analysis support to notations that the absorption of methyl blue on the banana leaf absorbents adheres to the Legumar models characterized by the monolayer absorptions in exothermic environments. Ultimately, the experimental results underscore the impressive absorption capacity of banana leaves by basic dye in the aqueous solutions when compared to untreated banana leaf absorbents. That is our reference, and thank you all. If you have any question, please ask.
Participants, if anybody has any query, please ask. So thank you, Dr. Umesh, for this presentation. We don't have any query, so we are just moving ahead with the next paper, that is D43. Mr. Amiya, if you can hear. Amiya Chandrol. Paper ID 43. Yeah.
Am I audible, sir?
Yeah, you are audible.
जो जो वो डिफॉर्म वाले करंट वाले जो बात करते हैं ना उसको हम लोग पूछी होते हैं या पॉची होते हैं.
Amiya, if you are there. Mr. Amiya Chandrol. Please unmute yourself.
Yes, sir. Am I audible, sir?
Yeah. We can hear you.
Good afternoon, sir.
Please, okay. Good afternoon. Please make it on full screen mode.
Yes. Is it visible, sir, in full screen?
No, it is not visible in full screen. I think you should reshare.
Okay, sir.
अभी देखिए यहाँ पास हो गया वीडियो ऑप्शन तो क्या आएगा इसका अनुमान से ठीक है ठीक है ठीक है अनुमान से
Is it visible, sir, in full screen now?
No, it is not even visible now. I think you should disconnect and again reshare that. Yeah, now it is on full screen mode.
Okay, sir.
Now we can proceed.
Okay, sir. Good afternoon, sirs. I am Amit Chandral, and today I am going to present a presentation on parametric study for modal analysis of inflatable torus. These are the outlines of my presentation. I will discuss about the introduction, numerical implementation of overall added mass of air, results and discussions, conclusions and references. Moving further, I will discuss about the introduction of space structures which are made of membrane structures. Gossamer structures, which are popularly also known as the inflatable structures, are made of membrane structures that can occupy the exceptionally large area in the space, which can be used as we can say that the satellite reflectors for deep space exploration, remote sensing, etc. These inflatable structures have low stowage and high in-orbit volume. These structures possess very lower cost and due to the exceptional packaging efficiency, and we can easily deploy these structures into the space. An inflatable torus is a donut-shaped membrane structures, like we can say the tube of a tire, that may be inflated or extended in space with the use of enclosed pressurized air, and it functions as a support structure for a range of space-borne structures, including communication satellite reflectors. These type of structures are always susceptible to large vibrations because these structures cannot support any compressive or bending stiffness. So these possess the very low structural stiffness and material damping. So these structures are more susceptible to the mechanical vibrations. Sorry. To improve the ability to control the vibration, structural stability and integrity, we need to we can say that analyze the model characteristics or find out the model behavior of the inflatable torus. Earlier, while studying reviewing the various literatures, all of them were study about the weight of the torus, but they were not calculated the mass of the air which is inside the torus and also in atmospheric condition or inside or outside of the torus. So here we added the mass of the air which is inside the torus and also outside the torus, and the mass then added to the converted into the density of the torus, and this is the formula given here. Then moving further, results and discussions. I performed modal analysis initially for getting the we can say that the convergence value. We have taken different elements for the analysis. Like in table 1, we can see that the number of elements are 400, 3014 and 9006, and we observe the various values, and by refining this is 9006 is the more refined value of elements, where we get the 6.51 hertz of natural frequency in mode 1. So this we can say that the refining is more important, so that we can get the converged results. And also here then I performed the modal analysis, and then we I showed here some modes, mode 1, mode 2, mode 3, mode 4, mode 5 and mode 6, and we get various different types of modes. First one is out of plane bending mode, second one is the in plane bending mode, and so on. And I also validated these results with Jha et al, where you can see in the table 2 that the results are very much similar as in my analysis and what Jha et al performed. Moving further, I studied by changing various parameters then can affect the natural frequencies or mode shapes of the inflatable torus, in which the first one is overall added mass of air. Here what we did that we added the mass of the air, internal and external mass of the air, into the torus, and then calculated the natural frequency of the torus. And in table 3, we can see in the first row, the mode number 1, the natural frequency we get without adding the mass of air 6.51 hertz, and when we add the mass, then we get the natural frequencies 2.26, which is we can say the reduced drastically, and we can say that logically we can explain that the natural frequencies depend on the stiffness of structure or material, mass of the material. So we can say that if we add the mass of air into the torus, so definitely we get some reduced frequency because the mass is increasing. So we also get from the also results also. And moving further, another parameter is thickness. And sorry, here we have taken three different thickness of the membrane structures. First one is 25 micron, second one is the 50 micron, and the third one is 75 micron. And we can say that the as earlier I said that the frequency, natural frequency, depends on the stiffness and mass properties of the structures. So if we increase the thickness, the stiffness increases and also the mass increases. So the relationship between both of them is little bit complex. So the more we can say that the what we can say, the more effective parameter, or it could be the stiffness or mass, then the value will change according to that. So here we can see from the figure that when the thickness is 25 micron, the frequencies are coming much more or greater than the when the thickness increased. So we can say that the here stiffness increases relatively lower than the mass. So that's why we get the lower frequency when we increases the thickness of the membrane structure. Another parameter is the internal pressure of the enclosed air. If we increase the internal pressure of the air inside the torus, logically we can say that we are increasing the stiffness of the torus. So also we can say see from the figure 5 that if we increase the internal pressure of air, Like we can say in the blue color, the pressure is inside pressure is 1000 pascal, and when red one is the 2000 pascal. So the frequency coming for the red one or the 2000 pascal is more than the 1000 pascal, because while increasing the pressure we increasing the ultimately the stiffness of the structure. And the last one is the aspect ratio. So here we can I took four different aspect ratios, 0.04, 0.08, 0.8.
Amir, sorry to interrupt you.
Yes, sir.
Please compile in a minute, please.
Okay, okay, safe. So we can see here that the while increasing the aspect ratio, the natural frequencies increases. Now the conclusions we get that the while performing the modal analysis of inflatable structures, we get different kinds of mode, which like out of plane bending is there, in plane bending is there, and when we consider the mass of the air, the natural frequencies decreases significantly, and other parameters like increasing aspect ratio and enclosed air pressure, it will increase the natural frequency. But when we increase the thickness, the natural frequency decreases. These are the references. Thank you, sir.
Thank you, Amir, for this presentation. So from the audience, if any queries are there. Okay, so from the audience, there is no queries. So thank you, Amir, for this presentation.
Thank you, sir. Thank you so much.
Okay, so now I am inviting paper ID D63, D64, that is from Akansha Kumari and Dr. Lalita Kumari. Akansha, can you unmute yourself? Akansha.
Am I audible?
Yeah, you are audible. Please share.
Okay, sir. Sir, is my screen are visible?
Yeah, it is visible, but put it in a full screen mode.
Okay, sir. Now is it visible?
It is still in the presentation mode. Please make it. I think it is taking some time. Is it? It is on full screen mode from your side.
Yes, sir. From my side, it is in full, sir.
Okay, so proceed. Proceed.
It's not visible in full size.
Yeah, it in our system it is not in a full screen mode. If you are comfortable, please proceed.
Okay, sir. So, good morning, everyone. I am Akansha, a third year student pursuing BTech in Computer Science. And today I will be presenting our research on fake news detection using machine learning techniques. These are the co-authors with me. Before we get into the details, let's see the outline first. We will start with the introduction and the problem we are tackling.
Kansha, sorry to interrupt you, but your slides are not moving. It is not changing.
Sir, I have changed from my side. Okay,
I
sir.
think you should reshare your screen. Just disconnect and then again reshare.
Okay, sir.
Hello.
Yes, Akansha, please share.
Yes, sir, I am sharing it. Sir, is it visible?
No, your screen is not shared yet.
Okay. Just taking time.
Akansha, please take your time. I am just moving to the next presentation, and
Okay,
after
sir.
that, I will allow you to present. Mr. Sumit Kumar,
Yes, sir.
please share your screen and present.
Sir, if it is visible.
It is visible, but put it in full screen mode. Yeah, from
Now?
there.
Now it is visible,
Yeah,
sir?
yeah. Now it is on full screen mode. Please proceed, and please try to complete by in 5
Okay, sir.
minutes.
Okay, sir. Okay, sir. Okay, sir. Okay. Good morning, everyone. Today I am here to present my experimental based research finding. Our study focuses on a sustainable approach to soil improvement using industrial byproducts, specifically blast furnace slag and red gypsum. Coming to the introduction, as our global population grows, so does the challenges of solid waste management become also become so in response we are exploring innovative solutions that align with environmental sustainability. This research delves into the effective utilization of industrial byproducts in the construction industry with a particular focus on road construction and stabilization. This led us to investigate the potential of two byproducts, red gypsum and blast furnace slag, which have proven application in civil engineering. Coming to the material and methods, before we delve into the findings, let's understand the key materials involved for this experimental work. Laterite soil chosen for its rich iron aluminum content forms in tropical and subtropical region. We also explored two industrial byproducts, blast furnace slag, a byproduct of iron separation, but a byproduct produced during iron separation in steel manufacturing, and red gypsum, a byproduct of titanium dioxide extraction. Additionally, we examined the particle size distribution of these materials to provide a comprehensive overview of their physical characteristics, which are shown in this slide. Now, experimental program. The experimental journey involved a rigorous testing program. The unconfined compressive strength and standard proctor test were conducted carefully, varying the mixed proportion of laterite soil with blast furnace slag and red gypsum. The goal was to identify the optimal doses of those two industrial waste to enhance the soil's property, including compressive strength and compaction characteristics. Now, our first mix was with soil was BFS with blast furnace slag. The first set of result focuses on the combination of laterite soil and blast furnace slag. The finding indicated that optimal doses of blast furnace slag range between 10% and 15%, resulting in a notable increase in both maximum dry density and unconfined compressive strength. This has promising application. This has promising application for sustainable soil improvement in construction projects. Turning our attention to the combination of laterite soil and red gypsum, we observed that ideal doses of red gypsum falls within the range of 5% to 15%. Our analysis indicated that 5% red gypsum achieves the maximum dry density, showcasing its potential to positively impact soil compaction. Furthermore, we note a significant increase in unconfined compressive strength with the addition of red gypsum. Now let's explore the combined effect of laterite soil, blast furnace slag, and red gypsum. We formulated various mixed proportions, including from specimen A to specimen F, wherein first three specimen blast furnace slag content was kept constant and red gypsum content was changed, and last three again blast furnace slag was percentage was increased to 15%, and again red gypsum proportion was changed. By carefully analyzing these six specimen, we aimed to determine the optimal mix proportion for achieving desirable properties such as maximum dry density and unconfined compressive strength. This is the graph plotted for unconfined compressive strength and the graph for dry density for soil plus blast furnace slag and red gypsum mix. Into the discussion part, we are into the comparative effectiveness of blast furnace slag and red gypsum in enhancing soil properties. Our research provides valuable insight into the specific doses of blast furnace slag and red gypsum for different purposes. This discussion not only highlights the technical aspects, but also underscores the broader significance of waste utilization in construction industry. In conclusion, our research contributes to ongoing discourse on sustainable construction practices and management. We have identified optimal doses of blast furnace slag and red gypsum for soil improvement, offering promising avenues for construction industry. We appreciate the opportunity to share our findings at this conference and look forward to further discussion and collaboration in the field of geotechnical engineering. Thank you, sir.
Thank you, Sumit, for this presentation. So from the audience, if any queries are there. Okay, Sumit. So there is no queries. Okay, thank you so much. Now we are moving to the next
Sir.
presentation, and that is D64 paper. Akansha, are you there? Akansha.
Yes, sir.
Okay, so I'm just sharing your presentation. Okay, and you will guide me to move to the next slide. So I will do that.
Okay, sir. Thank you.
Akansha, are you able to see the slides?
Yes, sir. I am able to see the slides.
Okay, so proceed with the presentation.
Oh, okay, sir. A very good morning, everyone. I am Akansha. Today, I will presenting our research on fake news detection using machine learning techniques, focusing on the application of various models and methodology to address the issue of misinformation in the digital age. Next slide, sir, please. Before we get into details, let's see the outline first. We will start with introduction and the problem we are tackling. Next, we will talk about what aim to achieve in our research. Then we will explain the methods we have used. After that, we will say how well our machine learning model performed. And lastly, we will wrap up with conclusion and look ahead to what we can explore in the future. Next slide, sir. So, in introduction, in today's world of quick information through social media and online news, fake news is a real concern. It's not just about false stories, it's a threat to making informed decisions and maintaining social harmony. This research dives into how machine learning can help us combat this challenge. Next slide, sir. So, fake news is a malicious misinformation disguised as a credible journalism spread to promote a specific agenda. Fake news can cause public panic, harm reputation, influence voting outcomes, and damage society trust in media. Identifying fake news is a complex task due to varied nature of languages, sources, and contexts. It requires a sophisticated approach, and machine learning and deep learning can help us detect fake news and promote reliable information. So, next slide. The concept of fake news is not something new. This research considered news articles and text to achieve better accuracy in detecting fake news and focused on performing machine learning and deep learning algorithms to build models which achieve promising results. If I talk about importance, our research aims to contribute the global effort to combat misinformation and its harmful effects on society. Next slide, sir. This is our proposed approach. So we have used the Lyell data set, which is a source of labeled sentences indicating their veracity. The Lyell dataset comprises 16 columns and 12,788 rows was utilized for analysis. The Lyell dataset contains sentences with their speakers and their affiliations with labels representing the news is fake or not. Uh, in data processing states, uh, before analyzing the data sets, we did some important cleaning like removal of punctuation marks, spaces, and other unnecessary characters from words. First, we have do the tokenization of text data using NLP techniques to break down the sentences into individual words. Then used TF-IDF, which is term frequency and inverse diachromatic frequency, and bag of words to convert this tokenized data into numerical representation. Then used TSNE, T stochastic neighbor embedding, was used to reduce the data set's dimensionality, aiding in noise reduction and better feature extraction while preserving the global data relationships. Then we have visualized it all using the word clots, which is a Python extension. Then we have developed a column based on heat map analysis. Then we used grid search to determine the best hyperparameter tuning, ensuring enhanced performance. So now we have tested various machine learning models like logistic regression, naive Bayes, decision tree, random forest, support vector machine, neural networks, and AdaBoost classifier were trained and evaluated for fake news detection. Next slide, sir, please. So, this table represents the accuracy score of different machine learning algorithms considering various data configuration. As you can see that there are different machine learning models, and with this we have different data configuration like TF IDF without speakers and party, bow without speakers and party, and then TF IDF with speakers and party, and bow with speakers and party, and these are the results we have get for different models. These results provide insights into the performance of each model under different conditions. Our evaluations reveals that neural network models exhibited the best performance in detecting fake news. However, results vary depending on the vectorization techniques and model configurations. Next slide, sir. If I talk about conclusion, then the complexity of the first conclusion we can draw is complexity of fake news detection. Fake news is a multifaceted problem that requires attention to different aspects, including linguistics, data science, and ethics. Second is important of vectorization technique. The choice of vectorization techniques plays a crucial role in model performance and should be tailored to the specific data and objective. Third is variability in accuracy score. Fake news detection is not a one size fits all problem. Models need to be customized to address different contexts and challenges. So for future research, clearly we can see that the Lyell dataset is insufficient for determining whether the piece of news is fake or not. So the researchers can explore more advanced vectorization and modeling techniques, investigate other data sets, and address ethical implication for fake news detection. Next slide. These are the references we have used for this presentation. And thank you for all for listening me. If you have any doubts, you can say.
Thank you, Akansha, for this presentation. And you have selected a very good topic for the research. So, if anybody has any query, please ask. Okay, so okay, Akansha, thank you so much. You can now leave. And now I'm moving to the next paper, that is D44, and which will be presented by me only. So I'm just sharing my screen. Please, anyone confirm if it is visible, ma'am? Is it visible? Am I audible as well?
Yes, yes, Deepak sir.
Okay, thank you, sir, for confirming. So, good afternoon, everyone. This is Dr. Deepak Kumar Singh, and the topic of my presentation is analysis of plate with a variable shaped cutout. So, basically, we can just see different type of structure in which some cutouts is there, some opening is there in between. If you want to visualize, so we have windows in our homes, we have windows in our aeroplane, in trains as well. So I this is about that only. So I have just evaluated the stresses and the frequency of those plates or those panels in which some cutouts is there. And as you may remind that the cutouts are little curved at the corners. So because to just reduce the stress concentration, it is required. It is the research is about that only. So I will start with the introduction, then the methodology I will discuss, then some result and discussion will be there, and finally conclude. So basically, it is I just taken a plate element, that is two-dimensional flat structural element, which has thickness very small compared to the other dimensions, and they are characterized as thin or thick plates based on the plate theories. And for the modeling and analysis, I have used a finite element software, that is ANSYS Workbench, in which I have used 8 noded plate element, that is termed as cell 281 in ANSYS Workbench. And I have also modeled my plate based on the criteria of Indian Standard 800 1984, in which it is written that the minimum thickness of the plate is 6 mm, and below 6 mm it is considered as a seat. So on the left side, you can see a photograph in which some opening is there, and in that opening, fillet is written there. So if we just keep that fillet as 0, then the opening will be square one, and if we keep on increasing the fillet from 0 to 0.25 meter, sorry, then the opening will become circular one. So I am just changing the periphery of this opening and just calculated or evaluated the stresses, deformations, and the frequencies. And that is based on the three different cases, or you may say three boundary condition. So first boundary condition is the corner, we can say corner A, B, C, D, the outer corners of that panel. So in the first case, I have just clamped all those A, D, and C corner, and applied a load of 1732 Newton laterally on the corner number B. In the second case, the edges AD and DC are fixed, that is clamped, and the same load is applied as in the first case, that is 1732 Newton load laterally on the corner B, and in the third case, edge AD is clamped, only at AD is clamped, and a load of 1.732 Newton per meter is applied laterally on the edge BC. So, based on these three cases, I have evaluated my stresses. So in this diagram, you can see uh, by changing the fillet radius or fillet length from 0 to 255, sorry, 20, 0.25, that is 0.25 meter or 250 you can say. So by that, you can just see that the three curves are there of different color. So black curve is of case 1, the red one is for case 2, and the blue one is for the case 3. So you can see that when the panel is changed or the opening is changed from the square one to the circular one, the stresses are decreased because due to the less stress concentration. So based on these results, we can provide the curvature at the corners so that the less stresses are just accumulated at that point. In the next diagram, you can see the frequency distribution, that how the frequencies are changing by changing the opening of that panel. So in that case also there is a slight increase, but we want the frequency to be increased. So it is increased in this case when we change the opening from square to the circular one. So it is good for us to make it a circular one. Then in the last case, we can see the deflection, that is deformation in the plate structure. So again, we are getting a good response of the plate when the opening is changed from the square one to the circular one, and deformation is decreased by changing it to the circular one. So the circular plate is better, and in between also, as per our requirement, we can just change, or we can just calibrate, or just make the circular corners as per our requirement based on these results. So based on the results, based on the analysis so far, some conclusions are drawn. So stresses is lesser when the cutout is circular shape, which is quite confirmed by these results. And the frequency are also, actually it is insignificant, but it is slightly increasing, so this is good for our case. And deflection is also decreased, so it is also good if we use the circular opening in the panels. So thank you so much. These are the references I have used during the making of this presentation. So if anyone has any query, please ask. Okay, so if there is no queries, we can move to the next presentation, that is D70. So it is by Dr. RJ Victor, Dr. Kumar Pallo, and M. Purvesi. So again we have the recorded video. So I'm just playing that recorded video.
Everyone, and thank you for the opportunity to present my work at the International Conference on Innovative Science, Engineering and Technology. The title of the research is Quasi-Static Analysis of Fire-Damaged Non-Porous Manor House Cable Wall, which was researched by myself under the guidance of Professor Palaf and Dr. Borbey from Cape Peninsula University of Technology. I will start off my presentation by providing a brief background before moving on to the motivation of the current study. I will further then describe the methodology used in conducting this research before moving on to the results and the discussion, and then finally I will end off with the conclusions. Rights are worldwide classified under different categories based on their significance, with the highest significance being under the jurisdiction of UNESCO. In South Africa, a prime example of a World Heritage Site is Robben Island. Further, in a South African perspective, the heritage sites are classified under 3 different grades, with a Grade 1 a national significance, Grade 2 provincial significance, and Grade 3 local significance. 2 examples of these are the Castle of Good Hope in Cape Town and the Non-Parole Manor House in Paarl, which I will discuss further in this presentation. The motivation and the inspiration behind this research started off with a well-known fire that occurred at the Notre Dame Cathedral in 2019. A few months after this fire, a similar situation occurred in Paarl at the Non-Parole Manor House, where the house suffered severe fire damage. This has come to the realization that heritage structures are increasingly at risk of decay and progressive damage. Contributing factors include natural disaster, climate change, war, fire damage, and human interference. And in a South African context, a significant research gap has been identified in determining the structural response of these heritage structures, where suitable non-destructive tests has been proposed in previous research to provide the basis on which finite element analysis can be conducted to accurately describe the heritage structures. The methodology of this research is based on the heritage structural investigation of a fire-damaged masonry wall, which is the front gable wall of the Non-Parole Manor House. Ultrasonic pulse velocity testing has been conducted previously to determine the material properties, which assisted with the calculation of Young's modulus, Poisson's ratio, and the material density. Using these results, a finite element model has been developed and the accuracy has been determined through the comparison of the finite element reaction forces and manually calculated reaction force under gravity loading. The finite element model was further developed to conduct analysis of the fire damage wall in the following scenarios. Number 1, the current damage condition under gravity loading, and number 2, the theoretical reconstructed condition also under gravity loading. The initial finite model was developed with material properties obtained through testing on each zone of the wall, which is shown on the bottom right. Each color represents a different material property to accurately describe the total distribution through the wall. Further, the reaction forces have been calculated manually through static equilibrium equations, and the reaction force has also been calculated through the finite element analysis. The comparison between these 2 forces for each model has indicated an accuracy of above 98%, which indicates a highly accurate model. Following the confirmation of accuracy in this finite element model, further analysis was conducted under the 2 scenarios mentioned previously, the fire damage model under gravity loading and the reconstructed model under gravity loading, where the roof structure is assumed to be reconstructed. The von Mises stress distribution and deflection distribution has been analyzed for both scenarios. Comparing the 2 models, it is clear that the stress increases slightly with the addition of the roof structure based on the additional weight imposed. However, looking at the deflection, it indicates approximately a 30% decrease in deflection, as the roof structure will provide additional bracing. This highlights the importance of reconstructing the roof to avoid further collapse. In conclusion, the ultrasonic pulse velocity testing that was conducted previously adequately described the material properties of the fire-damaged masonry wall. The finite element model that was developed indicated a 98% accuracy through static equilibrium equations. The von Mises stresses increased due to the additional weight imposed by the reconstructed roof. However, the deflection in the wall decreased by approximately 30% due to the additional bracing provided by the roof.
I would like to express my gratitude to the Cape Peninsula University of Technology for providing me access to the laboratory, for the South African Heritage Resources Agency for allowing site access and various permissions on site, for the Construction, Education and Training Authority for assisting with funding requirements, and the non-parole site manager for general assistance and site access. Get the opportunity to present my research, and thank you for your time.
Thank you so much, Victor, for this presentation. I think Victor is not with us, so I am moving to the next presentation. That is again by me. So I'm just sharing the slides. And I will definitely compile it in 3, 4, 5 minutes, not more than that. Please, if anyone can confirm, is it visible? And am I audible too? Okay, so thank you so much. This is the other paper with the title Partial Replacement of Fine Aggregate with Plastic, Rubber or Electronic Waste for the Manufacturing of Concrete. So because we are talking about the waste management, so after getting this waste as a plastic, rubber or electronics, we can use these things by just by to just add to the concrete or cement to for the manufacturing of concrete. So these are the content of my slide: introduction, material and methodology, then result and discussion, and finally I will conclude. So concrete, as we all know, that basically it is a mixture of cement, sand, coarse aggregate, uh, admixtures and water. But to enhance this property, or just to check the property of this cement, using different kinds of waste or other things, we can just analyze the or making the concrete mix for that. So waste material which are just utilized in these studies are plastic waste, rubber waste and electronics waste. And we have manufactured M20 grade concrete with a water cement ratio of 0.5. We have just kept it constant so that we can just compare with the different percentage of these wastes. So M20 we have just manufacture. And the replacement of fine aggregate with the waste of plastic, rubber and electronics are by weight, and it is from 10 to 30%, with a gap of 5%, that is 10%, 15%, 20, 25 and 30%. And some tests are just performed after 7 days, 14 days and 28 days. And cubes, beams and cylinders are casted to check its workability, compressive strength, split tensile strength and flexural strength. So these are the first slump test has been performed. So these are the results for the slump using these different plastics with different percentage of the these wastes. These results are for the compressive strength, and three different segment of the curves you can see, in which three curves are there. So three curves are for different types of plastic, and the three different segments are for the 7 days, 28 days and 7 days, 14 days and 28 days. Then split tensile test was performed using these wastes, and finally flexure strength tests are performed. So uh, I'm just concluding. So the consistency of the fresh cement did not change after the partial replacement of plastic up to 20%. So 20% till 20% we have not getting any change. So the strength, but after that the maximum reduction in compressive and flexor states are reported, that is 19.4% and 10.2% respectively. Although there is no fluctuation in the splitting tensile test, the weight of each specimen is decreased as the amount of plastic aggregate grew, making the structure lighter. So that is again a very good thing. As we are manufacturing concrete, so we are making a lightweight concrete as well. The workability of concrete is unaffected by the addition of crumb plastic, the little pieces of plastic. The workability is unaffected. As more crumb rubber is replaced, the concrete compressive, tensile, and flexure strength decreases. So this is not good. The slump of the concrete has significantly increased when rubber tire crumb is added, and it is observed that the slump got worse as more samples has higher replacement percentages. So concrete becomes more workable as the percentage of electronic waste increases. So this is good for us, and it depends upon the situation as well. So these references we have used during the making of these slides, and thank you so much for listening. And if any queries are there. Yes, so if any queries are there, we can just I can address that. Otherwise, I will just close this session, because we have already we have completed all the papers. The presentation of all the papers are completed, and again we will meet in the next session, that is track 4 of today's session. That will be the last session as well of this international conference. So I'm again thanking everyone for joining this conference, as an audience, as a participants, and as a panelist. And thank you so much. We will again resume at 2 p.m. We will resume at 2 p.m., and then the last session will be proceeded. Thank you so much. Thank you.
शायद अब ले रहा है ना
डर लगता है भाई वो कुछ। और मैं साउथ सर को बोल रही हूँ, सर आप नहीं कर दो रिप्लाई ना, वो बोल रहे तो आप कर दीजिए।
दे रहा हूँ मैम को, दे दिया। Good afternoon, everyone. Welcome to the last session of our ICISTECH 2023 conference. So, the technical chair will be handed by Dr. Lalita Kumari. So, ma'am,
Yes,
would like to please. So, ma'am.
Thank you, sir. Good afternoon, everyone. Thank you. Now we are starting our last session. Today is our second day of this conference. Rajiv sir, are you there, sir?
Yes, I am here since half an hour.
Okay. Sorry, sir. Thank you, sir.
Is there any delay in the program?
No, sir. No delay, sir. Just we are starting.
You
Okay,
told
sir.
me 1:30. ठीक है, let us start.
Okay, sorry, sir. Before starting the session, I would like to introduce my keynote speaker, Professor Rajiv Srivastav, sir. Sir is currently working as a professor in the Department of Computer Science and Engineering, head of the Center for Computing and Information Services, CCIS, and the Dean Resource and Alumni Affairs, Indian Institute of Technology, BHU, Varanasi. He also served as head of the Department of Computer Science and Engineering during August 2017, December 2020. He holds the degrees of BE, ME, and PhD, all in computer science and engineering, and possesses 25 years of teaching and research experience. He is a fellow of Institution of Engineers, India, FIE, Institution of Electronic and Telecommunication Engineers, senior member of IEEE USA and member ACM USA. He has published 93 research papers in reputed international journals, 88 research papers in conferences proceedings. Sir has published 20 book chapters, edited 1 conferences, and 4 patents published. He successfully executed research projects funded by MOE, Government of India, and DRDO, Government of India. He has produced 16 PhDs and 7 PhD scholars are currently working under his supervision. Sir, his area of interests are the image processing, image and video processing, computer vision, artificial intelligence, machine learning, deep learning, computational bioinformatics. Sir, now platform is yours. Sir, kindly unmute yourself.
Thank you for introducing me. There will be a half an hour talk as already communicated, and I have already shared my slide. I think slide is visible.
Yes, sir. Your slide is visible.
Okay, thank you. I will be talking about the fundamental basic concepts of AI, ML, computer vision, and research developments. So basically, if we talk about artificial intelligence, because nowadays everybody is talking about AI, but AI is not a new field, rather than it has been researched since long and since many decades. But it has got its attention in recent years, recent decades, much more due to the advancement of data and the kind of application we have. That's why researchers are concentrated that how to deal with the real-time problems and the challenges which we are facing. So if we go for AI, then what is AI and how the other fields are correlated? That first we'll discuss about those things. So normally AI is an area of research which is a combination of technologies that enables machines to act with higher levels of intelligence and evaluate the human capabilities of sense, comprehend, and act. Usually, there are 3 basic components of AI: sense, comprehend, and act. And the related technologies related to these three components include sense means fields related with sensors. For example, there are, as a human being, we have many sensors, our eyes, nose, ears, skin, these kinds of sensors are there. Similarly, in real-time environment regarding machines, we have various kinds of sensors to capture the data. Basically, the task of sensors is to capture the data. And if it is related to our human visual system, our eyes, human beings' eyes, then it is related to computer vision field. If it is related to our speech, then it is your audio processing, and similarly others. Next thing is that after acquiring the data, how to comprehend or how to understand or how to organize that particular data. Normally, there are some related fields which are natural language processing, knowledge representation, and all those things are there. Once you have organized that particular data, you have, then next thing is that what to do with that particular data. The next thing is the act, where we apply the various learning processes, machine learning, deep learning based approaches to learn that inference, to learn that particular data and to make future predictions based on that particular data. So these are the three basic components. And similarly, I will be talking about computer vision, IoT, and machine learning and its related applications. So normally, this is the analogy which has been shown between the computer vision and a human being. As a human being, we capture any image or video through our eyes, then we understand, we interpret that particular information, whatever we have learned through our mind till our birth, then we analyze that particular information and we give its interpretation. Similarly, in computer vision system also, we capture that particular data from various imaging devices, and then we prepare that particular data, process that particular data, and then learn that particular data by using machine learning algorithm, and then derive certain inferences from that particular data. Normally, it is a image processing, computer vision, and machine learning. These are basic fields of research which are highly correlated, and it finds its applications in various domains, including neurosciences, cognitive sciences, information retrieval, speech, robotics, machine learning. Everywhere you find these applications. Normally, computer vision is driven by advancements in multiple fields. But this is a highly interrelated field, and it is also correlated with all these associated fields of research. Normally, if we talk about what are the components of a computer vision system, so normally there are three basic components. First one is the image processing, second one is image analysis, and third one is your image understanding. Image processing, basically input is a single image or set of images, and output is a processed image. Normally, image processing steps are applied to prepare that particular data before applying any image analysis or image understanding method to understand that particular data. Normally, image processing may include their transformation of that particular data, format conversion of that particular data. If the data is of not good quality, then applying the image enhancement technique, image restoration technique, and sometimes image segmentation techniques are also there. So input is image and output is some processed image. In image analysis, it is a normally low-level image analysis, which includes the edge detection, segmentation, feature extraction, all those informations which are going to be computed from the image about the objects, which are various objects present into the image, so that we can further analyze those objects. So the image analysis techniques are applied. So normally, the input to the image analysis system is the set of processed image, and output is certain kind of measurements. And then third component is your image understanding. Third component is image understanding, where the input is image or it may be some set of measurements, and the output is the high-level description or high-level understanding about that particular data. Means it may be regarding the prediction of data, it may be regarding providing the class of that particular data, or providing the description of that particular data. Means how to recognize that. This is basically object recognition, classification, and prediction problem. So here we apply those things. Normally, if we go for the framework of a computer vision system, so normally this is the framework of a computer vision system. If you see the left-hand part, the left-hand part is basically data analysis part. That is also known as image analysis part. Right-hand part is conclusion from analysis, means that is your image understanding part. So data analysis part is one of the very important steps based on which the output and performance of any computer vision system is defined, especially in data-driven environment. Normally here the input, if you can see this particular diagram, the input is a image or set of images or database of images or clip of video frames those things may be there. Next is image processing, pre-processing. As already told, it may be either conversion of image format, conversion of color image into gray image, or in any other color space conversion that may be there. Some certain times we would not like to process that particular data in spatial domain itself, rather than we would like to work into some transform domain. It may be discrete Fourier transform, discrete cosine transform, Walsh-Hadamard transform, singular value decomposition may also be applied for factoring that particular data, or we may apply any other transformation, wavelet analysis and other things. Once we have converted that particular data in appropriate format or appropriate space, next thing is that we have to also look for whether the data is of good quality or not. If it data means for a particular purpose, sometimes there may be no noise into that particular image, but we may be interested in highlighting those details of the objects which may have been obscured during its acquisition. So we may be interested in applying the image enhancement techniques. Sometimes input image itself may be degraded at certain times, and those scenarios we may be required to remove those noise by applying various filters. So image restoration problems may be applied there. So once we are prepared with that particular data, because this is one of the steps which requires most attention. And next thing is that segmentation, means how to segment that particular object, because we are interested in interpreting the various objects present into that particular image. So normally segmentation may be preceded by the feature extraction. Sometimes edge detection and other methodologies may be applied to segment that particular object, or any other segmentation approaches may be applied. Usually, if you go through the literature, various segmentation approaches are available. For example, thresholding based approaches, region split and merge based approaches, clustering based approaches, rough set based approaches, graph based approaches. The literature is full of the methodologies. We have to choose an appropriate methodology which suits well for our application, and so that it can extract the region of interest or extract the objects which we are interested in. Sometimes segmentation is also one of the research fields. Sometimes we talk about semantic segmentation, sometimes we talk about instance segmentation, or sometimes we also talk about salient object detection, salient prime object segmentation. So once we are done with this step, we've identified the object, next thing is that we have to reduce the dimensionality of the data. So for reducing the dimensionality of the data, we normally use the feature extraction technique. Suppose we are dealing with a database of 10,000 images or 1,000 images, and we are designing an automated system to classify those images into various groups. So obviously, if you are going to process, suppose a single image is of size 512 into 512, means how many pixels are there? 512 into 512 in gray level image. If it is a colored image, it will be multiplied by 3 if it is having the RGB components. So number of data points which are going to be processed will be very large if there are multiple number of images. Suppose 1,000 images are there, the amount of data that will be required to be processed will be 1,000 into 512 into 512. So this amount of pixel values has to be processed. So what we are interested in, rather than processing the whole data, we are only interested in its attributes and property. The next thing is that feature extraction. Feature extraction is nothing, just associating certain attributes with the object that can characterize that particular object. For example, as a human being, I am a biological entity. I am associated with my name, roll number, ID, or whatever there. These are our features through which I am uniquely identified. Our Aadhaar number is there, our specific biological features are there. In a similar manner, if we can identify an object by using less number of features, then this is known as feature extraction. Normally, there are various feature extraction techniques. Normally, we may apply principal component analysis for feature mapping. We can extract the eigenvalues, or shift search. Many methodologies are there. Or you are more interested in low-level image analysis, then you can go for histogram-based feature extraction. Those are derived from statistical central moments. So normally, these are mainly mean, variance, kurtosis, and all those things are there. These are unique for different images. Similarly, if you are interested in analyzing the shape of an image, then normally various shape or shape analysis is there. In that case, you may find out the area of the object, orientation of the object, maximum bounding rectangle of that particular object, minimum and maximum radii of that particular object, compactness ratio, and many other features are there which can be calculated mathematically for that particular object present into the. It will depend upon the kind of application in hand and what you are going to do. Certain times, color feature of that particular object is also important. You may be able to extract the color feature. Certain times, texture features play a very important role. Texture surface details of that particular object means fine details of the object. So in that case, various texture features may be extracted, and for that particular purpose, if you refer to the literature, many methodologies are there. If you go back into 1973, there is a GLCM matrix, gray level co-occurrence matrix derived by the Harelix. So he derived 21 to 23 texture features. So we can compute those features. Now, if we come similarly, apart from GLCM based features, there are GL gray level difference matrix based features are also there. Similarly, loss texture energy based features are there, Gabor features are there, or nowadays we are also talking about since many years linear binary patterns and its variants. So many methodologies are there, and we have to see what kind of features. Suppose out of these n categories of features, you have identified few features from each group, and suppose you concatenate them, then suppose there are only 50 features which are going to uniquely characterize that particular object. So in that case, we will say that we have extracted a feature vector for a given image. So in place of 512 into 512 matrix, now we have a row vector of 50 into 1, means 50 features in one dimension. Similarly, for 1000 images, you will be having a feature matrix of size 1000 into 50, means where each rows belong to various samples of various images and each column belongs to the your features. So rather than processing those 1000 number of matrices, now we are going to process only a single matrix of size 1000 into 50, that is known as feature vector space or feature matrix. So this is how we deal with the feature extraction. Sometimes feature selection techniques are also important to apply, because once we are going to extract the various features, those features, some of the features may be redundant in nature. Some of the feature may not be relevant in nature. So we have to also apply the various approaches. Various methodologies are applicable into the literature. For example, filtering based approach, wrapper based approach, hybrid approaches are there, which are aimed towards finding out reducing the size of that feature set, means finding out a subset from the given feature set which are more relevant in contributing towards the decision making process. So once this is the very much important part in any computer vision process, and once you are done with this feature extraction and extraction of the object, next thing is that we may also deal with the symbolic representation or object representation. So these things are required to store that particular extracted object into the computer memory, so that these processes are not required again and again. So if you refer to the fundamental concepts of object representation and those things, so you will find the various object may be represented either by its boundary or by its inner region. So for boundary representation, we have various methodologies. For example, chain codes are there, signatures are there, or if you go for defining that particular object by using their region or content, then various data structures, image analysis data structures are there. For example, quad trees are there, run length encoding approaches are available there, projection methods are there. So many methodologies are there which may be used. Once you are done with these processes, next thing is that to understand that particular data. So for doing so, we have to choose an appropriate machine learning model. And train that particular model. So for training that particular model, at first we have to divide this particular feature matrix into two parts, train part and test part, normally in basic cases. So normally for dividing, even for dividing this data into two parts, we have various statistical approaches. Means every approach is followed by have a scientific methodology. You cannot divide the data randomly. Either you can use leave one out method, leave m out method, random sampling based approaches, stratified sampling approaches, sampling with resubstitution. Many statistical approaches are there, and as a researcher, one should go into the details or cross-validation approach, K-fold cross-validation, 5-fold cross-validation, 10-fold cross-validation. Various approaches are there which can be used to divide that particular data into two parts so that data is balanced. There is no biases. With properties of all kinds of data should be present. Then we use this training set to train the machine learning model which we have chosen for. Once the machine learning model has learned the attribute, then we can use this test data to test the efficacy of the chosen model. So normally for testing the efficacy of the chosen machine learning model, we will measure the performance of the, because here the test data, their label and details are already known to us. So we can know whether our chosen model is working properly, whether it is classifying correctly, whether it is predicting correctly or not. What is the percentage of classifying, what is the accuracy, what is the precision, what is the recall, what is the F measure, and this area under curve in ROC. So these performance metrics may be used to analyze the performance of the algorithm. If it is not up to mark, then we can do some parameter tuning and all those things. So once we are done with that, whatever the data which was available to us, we have tested that this system is performing better. Now this can be deployed for real-time unknown data so that in anticipation, it should perform better. So normally these are concepts which are basic concepts of machine learning. It may be supervised machine learning, unsupervised machine learning. And here the performance is data driven. So here for one set of data, performance may be 80%, for another set of data, performance may be 82%. So these variations are there that we have to be very careful. This is the overall process of any computer vision and machine learning processes. Normally, there are various societal applications which are of AI and vision. We can work in healthcare domain, security and surveillance domain, agriculture domain, smart mobility and transportation, smart cities and infrastructure, education. Some of the applications may be disease prediction, video surveillance, human activity recognition and behavior analysis, image forensics, automatic path planning and navigation, crowd management, and many other there. Similarly, there is also another highly correlated field nowadays, IoTs. So I will also give a brief idea of IoTs because we are now also dealing with the computer vision. So normally when we define IoT, so its initial definition was that the Internet of Things is a network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensor, actuators, and connectivity, which enable these things to connect and exchange data, creating opportunities for more direct integration of the physical world into computer-based systems, resulting in efficiency improvements, economic benefits, and reduced human exertions. So normally, in 10 years ago, 15 years ago, we were concentrated only on these things. We were concentrated on connecting the things, connecting the devices, having internet access, their IP addresses, they can capture some data, they can store that particular data in cloud, they can communicate with each other and all those things. But AI and data analytics was not there. But nowadays, the system has become more expert where we are talking about the edge computing, we are talking about the data analytics on real-time scenario as well. So here, so normally, if we see what are the components of IoT, so normally there are 6 basic components which we have to understand. First one is component is it deals with the device connection and connectivity. Second deals with the data collection through sensor and devices. Third one is your data transport and access. Fourth component is data analytics. Fifth component is data value defined by access. And sixth component is human value apps and experiences. So these are the 3 components which makes the overall system. So people have, researcher work in these fields cooperatively to design a complete solution. So normally, if we see in more detail what are the basic things which are involved. So in device connectivity, we talk about IoT devices and its connectivity, embedded intelligence. So what concepts will be required to support this particular idea to design those things? Basics of hardware architecture, connectivity and interfacing of devices, microprocessor, microcontroller. If you have studied this as a student, then this may help you in fabricating, designing, and establishing this information. Data collection basically deals with data sensing and collection and storage. So here sensors, actuators, basic or multi-sensory database and storage. Communications, how to these devices communicate with each other. So normally we use access network. We have to study the concept of networking, cloud, edge data transport, and security. In data analytics, usually the computer science people or IT people, which they are interested in analyzing that particular data by using AI, vision, machine learning, deep learning, and various methodologies. Then next part is data value, means analysis to actions, means development of APIs, software tools, etc. Human value means smart applications tuned to the need, and design a prototype integrating hardware and software. We talk about these six components. So now we are entering, rather we have entered into the next phase of IoT evolution. In the first phase, we focused on connecting devices, aggregating data, and building up big data platforms. In the second phase, the focus is shifting to making things more intelligent through technologies like computer vision and deep learning, generating more actionable data. So normally these are the various application areas: building management, security, surveillance, energy consumption, agriculture, automation, vehicle, all those, at all places you will find these applications. Normally, if you talk about the architecture, means if you want to understand the software part of that particular, so normally the IoT architecture model, this is one of the reference model that may be taken for understanding purposes. So normally there are three basic layers. One is your IT enabling technologies, hardware, that is bottom. Then IoT software platform, and then IoT applications. The IoT software platform, it basically works like a middleware as it works into distributed computing systems. And IoT applications, various APIs, tools, and technologies through which we communicate with the hardware via this middleware, the IoT software platform. The design and development of these things are also important. So normally, in IoT software platform, service-oriented architecture, and in a generic service-oriented architecture, 4 layers are defined. Means these three middle one. It has again a 4-layer architecture. One is sensing layer, another one is network layer, third one is service layer, and fourth one is your interface layer. So this is how. And in service-oriented architecture, for a middleware in IoT, this is the some kind of components or abstractions which are there. Means objects, means components, object abstraction, service management, service composition, and application. So this is a stack kind of development, software development, and where we built one application above the other, so that user is not aware about the internal details, what is being there. And if there is some error at some level, it may be get rectified. And normally, when we design any IoT-based software or hardware platform, so there are certain design challenges which we have to keep into mind. First one is your availability, reliability, interoperability, scalability, performance management, security and privacy is also another issue, big data analytics, cloud services, and smart service design. These things has to be kept into mind. Normally, computer vision, since I am talking about computer vision, the computer vision coupled with IP connectivity, advanced data analytics, and AI are the catalyst for each other, giving rise to revolutionary leaps in IoT innovations and applications. So now we are talking about this, hence our research should also be oriented to that. So this again some basic things about computer vision and machine learning. The vision and learning now go hand by hand. Normally, if we talk about why machine learning, normally some definitions are there from literature that usually the real world problems are NP hard. Sometimes, most of the time, they are ill-defined. Hello. Yes. ये मैं भी आपसे बात करता हूँ. I am delivering some lecture online. Or sometimes right answer may be subjective, sometimes hard to model. Then what does this machine learning? It tries to use statistical reasoning to find appropriate solutions for tackling the above difficulties. Then we talk about as a teacher or when we teach to the student for first time or when we study it, then we talk about how to study the machine learning. Then we talk about what kind of learning algorithms are there. And normally supervised, unsupervised, semi-supervised, reinforced, and deep learning based. Now we are working on deep learning based approaches. So before understanding the deep learning approach, everyone is recommended to at least go through these data-driven machine learning models, supervised, unsupervised, because they will teach you the basic understanding of the machine learning approaches. So normally supervised learning based approaches are those approaches which works onto the labeled data. Unsupervised learning approaches are those approaches which work onto the unlabeled data. There is no caption. Semi-supervised learning, as it is suggested, that it works onto the mix of data. For example, in some scenarios, we may not have sufficient labeled data, but we may have some labeled data and most of the unlabeled data. Then we can mix those kind of data and we can have a semi-supervised learning based approaches. Nowadays, we are also talking about reinforcement learning, where we work on feedback and other corrective mechanisms are there. And the overall, in last 10 years, since last 10 decades, especially in last 5 to 6 years, and nowadays, people are concentrating on deep learning, means architecture which rules all the things, with all the limitations which were there with conventional machine learning algorithms are not there. And also the basic, if we compare the conventional machine learning, supervised, unsupervised, reinforcement, and all those learning, semi-supervised learning based approaches. So when we increase the amount of data, the performance of the conventional machine learning algorithms may not increase after a certain limit. It may stagnate because they have their own convergence property and their limitations. But the beauty of these deep learning based approaches is that with the increase in amount of data, amount of learning data, the performance increases. So that's why for big data, for huge data, these deep learning models are very much useful nowadays, though it is associated with extra computational cost. It requires time to train. It requires special hardware, GPUs, and all those things. But researchers are working to design the various deep learning based approaches, which are also not computationally expensive. The major emphasis is on those things. So here you can see these are the superset is AI, then ML, then DI. And this was the machine learning workflow, which I have explained to you earlier. So whatever the data is unlabeled, unsupervised, labeled, supervised, then feature extraction, machine learning, and then classification or grouping of objects, predictive model, or anything may be there. So if we go for this large picture, machine learning can be classified like this: supervised, unsupervised, reinforcement. Supervised, again, there may be either classification problem or there may be a regression problem. Similarly, unsupervised learning, there may be dimensionality reduction related problems, or usually in most of the cases, clustering based approaches or the reinforcement learning based approaches are also there. So here, this was the deep learning architecture, one architecture to rule them all. So we should go. So normally, these are the various methodologies which we study them. So now the various semi-supervised learning approaches, if you go to the literature, these approaches are very powerful approaches and still useful in many of the scenarios. It is not always the case that you go for deep learning and apply everywhere wherever it is required. Even for customized applications, you can use some dedicated machine learning based model and have your desired solution. So various semi-supervised learning based approaches, if you go to the literature, you will find constant clustering based approaches are there, distance metric learning based approaches are there, manifold based learning approaches are there, sparsity based learning approaches are there, and active learning based approaches are there. Certain applications are there where you can have the application of computer vision. So one is your automatic detection of diseases, cancer detection from diseases. This is one of the very conventional problem research from last 20 years, but still people are working to find out the best solution, because now we have the first diagram is the conventional machine learning based approach: pre-processing, segmentation, feature extraction, feature selection, then classification. This is also known as computer-aided diagnosis system, where we have a database of images and we are required to classify those images into the normal or abnormal categories, or benign or malignant, like that. Or these variants have been used in various applications. Some people use in plant lubricants, and some people use grading of foods. With any application area, you can use this where you want to group the object or label the objects with various annotations. Then you can use these approaches. Then nowadays, people are also working with deep learning based approaches. And this is the flowchart for conventional approaches. For example, a flowchart for the design of a computer-aided diagnostic tool for cancer detection from mammograms. Normally, usually we perform pre-processing, then segmentation, feature extraction, feature selection, then splitting of the data into two parts, train part and test part, then training the machine learning model, then we have the train attributes, then unknown images maybe go into the classifier part for testing purposes. Then we may get two classes of images, normal images, abnormal images. Then again, we can apply the binary classification on abnormal images if you want to further classify find out the abnormality, whether it is benign or malignant. This is binary classification. Similarly, you can proceed for multi-class classification problem as well. Major thing is that it will depend that what kind of problem you are working, what is their pathological features if you are working with the medical image, what are the features, and how their physical features will be associated with mathematical features. So those important things will be there. For example, for this application, pre-processing, image restoration using total variation based method adapted to Poisson noise statistics followed by adaptive histogram equalization was used. Segmentation, for segmentation purposes, unsharp masking and clustering method was applied. Then modified fuzzy C-means thresholding based image segmentation was used. Then for feature selection, we used a hybrid feature extraction. Histogram based, texture based, geometric based, wavelet, and Gabor. A total of 88 features were extracted. Then features selection was applied. Then 10-fold cross-validation was used to divide that particular data into two parts. So here, the selection of approaches at appropriate levels will depend upon the kind of application in hand and challenges which are associated with that particular data. So normally, then there is also a application where hybrid approaches are applied with automated abnormality detection for capsule endoscopic images using a hybrid approach of conventional machine learning and deep learning. Here, the major thing is that through capsule endoscopic, wireless endoscopic images, the human GI tract was monitored, and the abnormality, the task was to find out the abnormality, whether there is some abnormality, whether there is a ulcer, whether there is a bleeding, or whether there is some other kind of pathological changes into the whole abdominal or GI tract system. So how to analyze them? So for working with that particular problem, again, same set of methodologies are used, but the limitation was that the amount of data which was available was very less. Only few video clips were available. So in those cases, the transfer learning based approach was used, where we have a pre-trained network to classify 1,000 classes, and we also took these input images which were available to us. We performed the augmentation of the input data so that we can increase the amount of data, and we again use that particular data for transfer learning. Then confidence of prediction was computed, and if suppose confidence of prediction is greater than 85%, so we can take the result as an intermediate result and we can say this is the output. But if the confidence of prediction is less than 85%, 90% or 95%, it will depend what kind of accuracy you are. Then again, we can go with conventional machine learning based approaches. Then again, we can go for feature extraction for the available data. And then we have used ensemble classifier, which is a collection of weak and strong classifiers, and their outputs were decided based on the concept of majority voting. And then finally, output was generated. Then this kind of system may also work where you are available with less amount of data. Then another very good application is your salient object detection and automatic image annotation. So this is a problem which is related with computer vision as well as NLP, natural language processing. Here you can see that there is a image. If you interpret this image as a human being, suppose you can easily interpret. You can say that a person sitting on bed behind an open laptop computer and a cat sitting beside and looking at the top screen area. But system may say, if system is not properly trained or designed, it may say only those things which are completely visible to us. For example, a cat sitting on top of a bed, because other things are not visible. So here what we are doing here, for as a human, we are also using our deep learning, cognitive learning, and prior understanding to analyze this particular information. So this problem is also known as scene description or automatic image captioning problem. So here in these kind of applications, the major thing is that the object annotation means whatever the objects are present, we have to annotate them. Object annotation is nothing, just a classification problem. Means identifying the classes, identifying the labels to the various kinds of objects which are present into the image. If we go by conventional machine learning approaches, again we have to go through whole pipeline and we will classify these objects. Or if we are going to the deep learning based approaches, again it will follow the those internal processes. For example, various deep learning based approaches are available as a object detectors. This is the object detection problem or object annotation problem. YOLO, you may have heard. You look only once. YOLO version 1 and various versions are available. So once you have labeled the various objects, next thing is that detection of words. So here, the various words which may have been identified, maybe woman, crowd, cat, camera, holding, purple. Now the task of computer vision is over. Next thing is that to provide a meaningful description to this scene, we have to generate a meaningful sentence. Then here the task of natural language processing will come into picture. Then we will use the various NLP based approaches to generate the various possible sentences that may be generated by using these words. And then finally, we will re-rank these generated sentences according to their score or importance based on the image, with keeping in mind the other attributes. For example, blue score and other scores may be computed. And the sentence which is ranked 1 may be considered as the most suitable sentence giving the proper description of this image. So that is how this system works. This is also interesting domain. Many other applications are there. If you are interested to work in vision-based path navigation and autonomous vehicles, so normally for the design and development of autonomous vehicles, normally there are 4 components: sensors, perception, planning, and control. So out of these 4 components, as a computer vision and machine learning researcher, we may work into the perception and planning module. Sensor module is there to capture the various data which are going to be captured for further analysis by the vehicle. And perception module includes detection and localization modules. The various detection modules are there so that it can guide the driving of the vehicle, automatic driving of the vehicle. So all those possible tasks which a human being may encounter, they are designed, they are considered. Some of the possible examples include lane detection, traffic light detection and classification, traffic sign detection and classification, object detection and tracking, free space detection, etc. These are only few very prominent problems. So normally in this module, there are multiple modules like this one to here. Then next thing is that once you have decided, taken the decision, the next thing is to plan for further control. In the planning module include route planning, prediction, behavior planning, and trajectory planning, which route to follow, what is congestion level, and other things. So here, this planning module gives the appropriate information. The perception and planning module is one of the 2 important components which may be researched for further findings. And then based on the output, the control is transferred to the electromechanical devices, PID controllers, MPC, and others, to take the appropriate decision by the vehicle on the ground, whether it has to accelerate, whether it has to deaccelerate, whether brake has to be applied, whether it has to go into certain other direction like this one. So this is the another application area. Another interesting application area is your crowd management, which is application related to video surveillance based application. So here crowd management is basically crowd analysis, it consists of various submodules. It includes crowd count and density estimation, crowd behavior analysis, crowd flow analysis, crowd congestion level analysis, and crowd scene understanding. So itself, again, crowd management is a whole system which is meant to manage the flow of the crowd at very busy places. It may be airport, maybe railway station, bus station, mela, and other places. How to divert so that decision maker can take appropriate decision to divert the crowd to avoid any mishappening. So these kinds of modules are there. So many research has already been done, and still it is being researched, and people are trying to find out the real-time scenarios. So normally, if we go for crowd management system, so this is a kind of framework that we may have: video acquisition, frame pre-processing, then learning module is there, feature extraction, if it is conventional machine learning or deep learning, then learning algorithm, whatever you choose. Then crowd analysis. Crowd analysis may include abnormal crowd behavior, maybe people may panic, gathering may be there, running, fight, overcrowd, empty crowd, etc. Crowd flow analysis, like dominant motion direction, in which direction the crowd is going, with what crowd scene understanding, what is happening into the scene. Crowd congestion level analysis, whether congestion is very low, medium, high, very high, or it is free flow, it is moderate flow, it is restricted flow, or dense flow, and so on. So these kind of classifications are done, and various modules are designed. So normally, one of the submodules, as I already told you, crowd count and density estimators. Normally, it calculates the number of humans from the whole scene, global approach, or local to the scene, local approach. Following diagram shows the state-of-the-art approaches to solve this crowd count and density estimation. If you do the literature review, then you will find n number of approaches. First category of approaches are based on conventional machine learning approaches. Another category is deep learning based approaches. In conventional machine learning, various approaches are there. Count by detection, means classification and clustering based problems are there. Regression based problems are there, or density map estimation problem is there. Similarly, in deep learning based approaches, regression or density map estimation problems are there. So this same problem is being handled using various approaches, and their efficacy, performance, and other things are measured. And we use a particular methodology which suits well for our application. Similarly, a generic framework is maybe like this one. So internal details may be sought out. Similarly, if you go for a CCD using deep approaches, so many, for example, video, dataset preparation, pre-processing, then various approaches which may have been applied in recent past may include faster CNN, PCNet, pre-trained deep networks, net features, LXNet, VG16, autoencoders, LSTM, GANs, other hybrid graphical models. All these have been applied and people have reported their work. So what you can do, you can study those papers, you can find out the appropriate solution, and you can select a method which is appropriate for real-time scenarios. So normally, the output is designed based on the output of these systems. Similarly, this is the scenario of crowd anomaly detection. So we may design the various modules. For example, state-of-the-art technique for crowd anomaly detection. So normally, if you classify them from literature, because as a researcher, when we start certain research work into certain field, we try to understand the problem. What is problem? A statement given to us. What are the kind of input which are available to us? What is data which are available to it? And what kind of output is expected from us? And what is other issues related, maybe computational issues, which may have to address. And based on that, a method may be proposed. Before proposing a method, you go for the literature, you find out what kind of approaches are there, how people have worked, and what they have reported. If you go into the literature, you will find out there are various approaches: object-centric based approaches, non-object-centric based approaches, and density map approaches. These are three categories in which crowd anomaly detection problems can be classified broadly based on the study of the literature review. So here, in object-centric, trajectory clustering or trajectory classification problems are there. Non-object-centric may outlier detection or sparse reconstruction cost-based approach there. Outlier detection approach may clustering and their variants. One class classification problems are there, or density map approaches are there. So this is how we classify them and we work for an appropriate model. Similarly, these are the other classifications and crowd anomaly detection. Then crowd congestion level analysis is also there. So here it provides congestion level information at global level, means whether the congestion or is low, very low, medium, high. This is some kind of classification problem, just to give an idea what kind of congestion is there in the crowd. Other kind of this is the last application that we will talk about. The image and video forensics. It is also one of the very important and interesting field to find out the forgery from the image or video. It is related with tampering of the images. So here basic problem is that finding out the detection and localization of the forgery into the images. So normally forensic is a very generic term. So forensic science deals with the physiological forensics, social, digital, criminalistics. So normally, as engineers, as a computer vision researchers, we are here in digital forensics, data analysis, and or video analysis or image analysis. All those parts are there. The engineers are associated with them. So normally digital or video forensics, application of image or video science and domain expertise to interpret the content of an image or video or the image video itself in legal matters. So normally the question that come to mind and can be answered by forensic image or video analysis, whether contents in image or video are real or computer generated, where was the picture captured, from which device picture or video is taken, whether the picture or video is altered, tampered after taking, when was a picture or video taken, and history of the picture or video from acquisition to project. So all these questions can be answered from the image data itself. You can assume the power of data. You are available with only an image and matrix, its equivalent matrix, pixel values. Usually they define the color, gray level intensity to display them. But every integer value contains a lot of information. It is up to us how we are going to interpret that particular data. So normally, in image forensics, normally we deal with the analyzing the pixel informations to find out what are those regions into the image which may have been altered. The very popular examples are there: copy, move, forgery detection, alteration, and many other techniques are there. So normally, forensic other applications which can be grouped into different categories: image, video, forgery detection. Another interesting problem is that apart from detecting and localizing the forgery into the image, another interesting problem is that source camera identification and source device identification. Means if you have an image, if you have a photograph, and if you are able to tell that this image or this photograph was taken from a camera of this company, then you can easily reach to the people who you may find out the probability of suspect peoples that yes, these people are having Sony camera, other company camera, because each camera is manufactured having different specifications. What specifications we look for? We look for their whole image capture mechanism. For image capture mechanism, they use various kinds of lenses with their properties. They use various kinds of CCD sensors and others. It's during object to image formation process. Because when you take the image of an image, there is an object and there is an illuminating source. Because for taking the image of an object, that object must be illuminated. Illuminated means that object must be visible. If it is daytime, it will be natural illumination. If it is specific lighting condition, then certain illumination model, if you refer to the various illumination model into literature, there are various kinds of lights: ambient light, diffuse light, specular light, and a combination of all. And all of them have their mathematical properties. So that object is to be illuminated. And once that object is illuminated, that object is captured onto the camera film by using certain perspective projection approach or any other approach. Means this 3D object is imaged onto the 2D film. The overall processes are involved. So here you can also identify that what kind of illumination conditions may be there, or by what distance the camera was there, depending upon that particular focal length of the camera, lens, their chromatic aberration, their other properties, camera traces. So many physical traces are there. If you are able to understand those traces and correlate with the formation of the image data, then you can easily formulate a problem. This is some kind of classification problem. Only you will need some kind of initial test data, because you have to use multiple cameras to capture the various images in various conditions, so that you have the input data. You also know it. So this is also one of the very interesting problem, and many other approaches are there. Here, forgery detection techniques can be divided into following general approaches: digital signature, these are active protection; authentication watermarks, it's also active protection. Here, what I am talking about image acquisition traces, passive protection approaches. Digital signatures, generic signature, robust signature image, all these active protection images. I am not talking about these things. Nor I am talking about digital watermarking, all those things. I am talking about analyzing the image data and finding out what are those regions which may have been altered. The alteration may be there. For example, there is an image, and in that image, one object from another image may be inserted. Okay, but it may look to you that it is, yes, fine, it is a part of this image. How you will do that? Normally, we use the various physical traces, geometric and perspective protection, lighting condition, lens and shutter properties, sensor traces, JPEG traces, metadata, various methodologies are there. Normally, noise patterns are there. If we see one of the very basic example, because these two images, one image, the original image, and one object which have been inserted into the particular image is imaged into the another condition. If you analyze their variance and other statistical properties, and once you reach to that variance and statistical properties of the image taken into same environment will be same. And for two objects, different images, they may be different. So we have to find out based on statistical analysis. Once you reach to the fourth region, you will find out the various variations into that particular image, and based on those variations, noise estimation, various techniques are there. Noise estimation parameters and other techniques are there. You can find out, yes, this is the area where forgery has been done. So this is how we work on this particular problem. And this is I was talking about this object to image acquisition process: light, lens, CFA, large number of silicon, CMOS, CDD. Many processes are involved. So we have to go back to the physical formation of those processes. And we have to, so these are some examples. So with this, I will stop here, and thank you for listening to me.
Thank you, sir, for your nice presentation. That you have the topic that you have covered today, computer vision, and you have given detailed discussion on machine learning, deep learning, how data should be collected, and after that feature selection, that's various algorithm that is available for feature selection. And the thing that you have discussed today is that how computer vision and then the IoT system that we have. So all the topics that you have covered, and very well and nicely you have presented, sir. So sir, we would like to hear you in future also. And thank you, sir.
Thank you.
Thank you, sir, for accepting our invitation. Thank you.
Welcome. Thank you all.
Thank you, sir. Yes, dear participants, our next keynote speaker is Dr. Manoj Kumar. Sir? Hello? Manoj, sir?
Yes, ma'am. Yeah. Am I audible?
Yes, sir. You are audible, sir. Only we want confirmation that you are here or not. Okay, thank you, sir. Before
Thank you.
starting this keynote presentation, I would like to introduce our speaker, uh, Dr. Manoj Kumar. So, Dr. Manoj Kumar, sir, completed his PhD from the North Cape University and MSc in Information Security and Digital Forensics from Technological University Dublin, Ireland in 2013. He received fully funded a scholarship for the MTech and MSc program from Irish government and MHRD respectively. Dr. Kumar have more than 13 years of research, teaching, and corporate experience. Dr. Kumar is currently working on the post of Associate Professor Cybersecurity in the University of Wollongong in Dubai, UAE, and Research Head for Network and Cybersecurity Cluster at UOWD. Dr. Kumar is in the world of top 2% computer scientists list. He has published over 170 articles in international referred journals and conferences. He published over 10 patents and delivered 3 international research funded projects. His specializations are digital forensics, machine learning, information security, image processing, IoT, and computer networking. Sir is the member of numerous renowned professional bodies like IEEE, ACM. Dr. Kumar received the Best Researcher Award in 2020 and Outstanding Scientist Award in 2021 and a Young Researcher Award in 2021 from recognized international professional scientists. Thank you, sir. Now, stage is yours.
Yeah. Thank you, ma'am. And thank you for such a wonderful introduction. And I'm honored to be part of in this conference, ICIST Tech 2023. And today I'm going to deliver my talk on one of the trendy topic that is also related to security. So that is an ensemble framework that we designed for detection of the DO traffic, DNS over HTTPS. Let me share my screen. I think it's visible, right?
Yes, sir. Your screen is visible.
Okay. Let me put it on
Yes,
presentation
sir.
mode.
In presentation mode.
Yes. Put it on presentation mode. Yes.
Now it is, sir. Okay.
Yeah. Now I think it's visible
Yes.
to everyone, right?
Yes.
So even though like ma'am gave me my introduction to all of you, so I'm working in the Department of Computer Science here in University of Wollongong in Dubai. So we have one more branch in Australia, and being part of this organization, I'm also handling as a research cluster head position that's in my network and cybersecurity research cluster. And the topic is inspired from there, like it's inspired from the security and like how we are implementing different security mechanisms here. We are delivering, and we also working in some of the research projects related to cybersecurity. So this talk is based on a framework that we designed, and it's a kind of ensemble framework for detection of the DNS over HTTPS traffic. And as a part of the introduction, and this is nothing but like the DO is already, it's one of the basic cybersecurity term. And if we want to understand like how this DNS, right? DNS works, and how the queries are to be placed over a server. So it's published in RFC 84 and 84. So the basic of DNS over HTTPS will be there. And DNS over HTTPS, and when we combine this, so this gives you like DO. And this is a protocol for performing remote domain name system resolutions via the HTTPS protocol. As we know, like HTTPS is one of the secure protocol nowadays. So compared to like HTTP, right? But the idea is there, like with the help of DNS queries, so attackers can steal useful information. And
And the main purpose of implementing this framework is to detect those malicious activities, by the way. And if from the as a part of introduction, you can see from the figure, like we have user computer and it's going to give a particular URL to the DNS as a DNS query to the server. And that's nothing but the server provided by your the service providers of any of the organization that you are using in your company, right? And then further the query is escalated to the root DNS server, and then it goes to your TLD, basically the top domain servers, where the query is to be resolved, and it's sent back to the root server, right? And from there, like when the query goes back to the DNS server, and it goes to the DNS query, or you can say the authoritative server, which is going to authorize that particular IP. Like, okay, the particular user is looking for this particular IP, and it's giving back to the address to that. So this is the process, like how this DNS query is to be processed over a network. But the idea is that, at any place, if you will see, like there are so many, there are like 8 steps basically. And this is a high level domain, by the way. And in there, at any of the link, the attack could be possible, right? So the idea is that, like, how we can protect the traffic, how we can avoid these caching and poisoning based attacks, on the medium and the middle based attacks when we implement DNS or HTTPS. So attackers attracts to perform cyber attacks, such as DNS spoofing is one of that, right? DNS amplification is, and the cache poisoning and eavesdropping. So these are the one of the some of the common attacks that you can say that performed on the network, right? Pertaining to DNS query. So another term is like how you can avoid. So there are like for technical perspective or technical implementation perspective, as a tool that you can use as a DNS load balancers. You can use the Open DNS that is by Cisco. Just one of the tool. One of the good tool that helps you to protect, and then you can apply the DNS filters as well. So these are some technical tools that you can use. And the main idea is that the attackers is going to, if they are performing any attack or performing like the spoofing or deleting some of the useful information, then their main motive is to modify the length and content of the incoming packets. And that is what the idea is there. So in this project, so we are trying to analyze the length of the packets. We are trying to analyze the content of the packets, and even though like there are other features also that helps you to get an idea whether that particular query or that particular request is malicious or not. And for that, as we all know that nowadays you can use the HTTPS and Bootstrap UDP. So these are some other implementation that helps you to protect the connections, or helps to protect the traffic data, right? So this is the working of DNS over HTTPS. Now, like how the DOE will work. So the idea is that, like, this is one of the implementation, and we also implement it in the real time. So it's a simulated task, as well as we implement it, like we configured a certain kind of DNS servers, and then we check like whether the proposed work or the method works in the real environment or not. So we have the local environment where your traditional client and local DNS over HTTPS proxy server is there, right? Or one is like DO enabled client is there, and then we are going to send the queries over internet, right? Or the ISPs or whatever is there. So external. So there we have the DO server. And in there, like as from the introduction, you can see that we have the implementation of a root server and the top level domain name servers and authoritative name server, right? So this is how the communication will take place, or you can say that the DNS or HTTPS take place between the local and the external or the over internet, right? And it helps to stop the third parties from analyzing the DNS. If you have enough security measures in your network with the implementation of DO, right? And this is how you can provide security to your traffic as well. And the main idea is also like to split the DNS in enterprise networks. If you have like more number of networks intact and then you want to implement. So it's just like the VPN. But the thing is that here you can't exactly say like it's a virtual private network placed at different location, but it is your DNS implementation over HTTPS at different networks of the same organization. And it is also be possible when we implement a DNS or HTTPS. Another like one of the important application is the CDN localization. That nothing but this is the content distribution network. So nowadays, like Netflix, YouTube, or any of the, there are so many these multimedia based organizations, right, which provide source kind of video or audio data, right? So they use this kind of security. So they also implement the DNS or HTTPS. Okay, the thing is that it's gives you the security basically. And as a part of the problem statement, so this is the introduction about like DNS or HTTPS, but what are different problems there? So the first problem that we identify is that like since DOS encapsulates a DNS messages within HTTPS, that's why it's a DNS over HTTPS. So encapsulation is there, and it makes the detection of DNS traffic and making the data vulnerable to attackers. So that's the first thing that we identified. Even though it's very challenging and to implement, like how you are going to avoid, or how you are going to work on this encapsulated data, like how you are going to truncate some of the information, whether the packet length or the content itself. Second problem is that the attackers use the malware, and they can use the HTTPS to connection to embed certain kind of malware or the malicious program with the help of do request without even creating or bypassing the security measures in your internal network configurations, right? So that's the another thing. The third is like due to the usage of new DNS resolver, and there's nothing but the do basically. And emerging new threats make it difficult to detect DNS tunnels and harder to mitigate it associated threats. As we know that nowadays, like attackers are very sophisticated. They're also using new AI based tools and techniques. Even though I'm doing one of the workshop on like AI in cybersecurity, where we are going to implement AI based methods to detect the malicious activities, to detect the malicious traffic, and also like like intrusion detection and prevention system is part of that. And classification is one of the problem that we are working on. The idea is that like nowadays, that why I'm saying, because the AI is very nowadays, like attackers are also using AI, and then also like security practitioners, they're also using the AI to detect and to take a proactive measures before any attack on their networks. And that's how like it's there. So because of the sophisticated tools and techniques, it's very tough to identify whether it's a kind of attack or it's a kind of seems like a real traffic data, right? So like true positive, true false, and false negatives are there basically, right? So that's another problem. And based on that, like there are, these are some problems, and based on these problems, so many researchers did a kind of work in that domain, where Doe et al. Uses the one class port vector machine and k-means algorithms to analyze the DNS tunnels in mobile networks. And they conducted a comprehensive study, like how the DNS tunnels are to be identified, and how they're like different machine learning algorithms helps to mitigate its effect. So a lot of research they did using machine learning based methods and AI based methods. Further, like Wang also like they conducted one of the comprehensive research for detecting the DNS tunneling. So but the thing is that these research are based on the detection of DNS tunnels, by the way. Okay, and they use like two type of approaches. So the one is a rule based, and while the second is model based. So in the rule based methods, they usually analyze the DNS tunnels by determining the that the traffic that they observed or they capture, and for that they define a certain kind of rules basically. So it's just like contemporary security mechanisms they implemented, or you can say there's a rule based approach, by the way. And then in the second one, they implemented the model-based method where they identified certain features from the training data, and then they tested it against various different type of model-based machine learning methods. Then one more researcher like Zhang et al., they also implemented a pre-processing based method to detect the encrypted traffic based on semi-supervised cluster method. And some other researchers like Anusha and Amin Stosa, they also implemented, they implemented their method to detect the HTTP, HTTPS, FTP, POP3, and DNS packets, and with the help of SVM to classify like what type of traffic it is, So there are like, they also identify certain kind of parameters from the traffic to identify it as malicious or non-malicious traffic. Then Mitsui also like focuses on detecting the malicious DNS tunnels, and they also analyze the DOE traffic. So this one is also based on the DOE rather than like DNS tunnel identification. And they use the tools like DNS TCP over DNS and tons with high accuracy, even though the method was very effective. And likewise, there are so many researchers who did kind of work in this domain, no matter like they identified the DNS tunnels or they directly identify the DOE traffic, right? The objective of this particular project is to design an intelligent, efficient, and automatic framework for categorizing two-layered DOE traffic architecture using robust machine learning techniques to classify DOE and non-DOE traffic at level 1 and level 2. So the idea is that we implemented, or as I said, like this is an ensemble approach. So it will work into different levels at two different levels. In the first level, we implemented 3 machine learning models, and on the another, and also like we implemented 4 different machine learning algorithms, and that's how this is to be classified. Like, okay, so this is at level 1 and level 2, and this provides a efficient capture model anomalies, and also tested and gives a better accuracy in terms of error optimization as well. And we compared the results with respect to state-of-art methods, and such as like XGBoost, random forest, SGD, logistic regression, naive Bayes, and decision trees. There are some of the methods that we compared with. And after comparison, we can say that the proposed ensemble framework is robust and gives more accurate results. There's the one thing. Another thing is that like we also implemented, or we captured a certain kind of real data, and we tested in that scenario. That's very complex. So the data size is not that much strong, right? Or it's not big basically, and we have a less number of captured packet related to that particular traffic. So that's with respect to the real-time implementation, not the database implementation. So this one is based on the database implementation. So we use this CIRA CIC 2020 data set. Okay, this is one of the data set that is available. And to analyze the DOE traffic at 2 levels, we merge these. There are 2 files, DOE and non-DOE. So we merge that file, and out of there, like more than 116,000 and over like 1.1 million records are there basically, and 35 columns for analysis, right? And for that, like how this for real implementation, like and as well, this database also consists of certain kind of data that you can see in the table, like it's generated during the Google Chrome, DNS2CP, DNS-Cat2, and Iodine. So these are the browser, and then they using the EdGuard, Cloudflare Required 9, same kind of those server is being used, and then they capture the packets, and there are like different packets are there, the number of counts you can see in the table, and that some of the like DNS2CP or DNS-Cat2 that helps to generate the malicious DOE traffic, while the Google Chrome gives you like HTTPS non-DOE and benign type of DOE. So the idea is that like we have this data set, we generated real-time data set as well, the data as well, and from there the idea is to detect whether it's like benign or it's malicious, or what type of traffic is this one. So these are the number of like you can see the distribution of DOE and no DOE data that is present in the data set. and you will see like non-road data have like more number of records there, and our count is very high. So when we count the number of data packets in the class, okay, so these are two levels. I mean, you can say that two levels are there on the data set, and this is how this is to be classified. So we are giving input as a dot HTTPS traffic data at two different levels. So when we are talking about at two different levels, so here we have like a explicitly we are using like different machine learning algorithms to analyze that, right? And then further the classification of dot traffic is being done with the help of machine learning based methods. And for evaluating, we implemented like different evaluation matrices, right? And that are like accuracy, false positive, and Epson score. So different evaluation matrices are being implemented, and finally classified like whether it is like that whatever be the level. So it gives you the classification whether it's a malicious or non-malicious dot traffic. So the step one is like pre-processing over data. So data is explored, data visualization, imputation is to be done. By imputation, because we have like over like 34 features from the data, and some of the features are negative, or like some of the features also have the null values, and that didn't make sense to when we analyze the data. So the imputation and visualization is part of the first the step of this proposed technique. And then we did the modeling where the feature normalization and the selection is to be done. And yes, again, important like how the features are to be selected, like what features you are considering. So that's very important. So based on the structuredness of the data, you can pick the parameter, right? So okay, let's say we are going to use one of the like okay, source IP I'm taking as a input parameter, and based on that I want to see like how this door traffic looks like, right? And that's how this is to be classified. So the thing is that in our method we can select different features, and then we can test it against the availability of like different data values are there, or the data is there. And then finally the model is being evaluated and the classification is to be done. So this is a model evaluation. So do and non-do data. So on the left hand side you can see these are the features in the data set: source IP, destination IP, or response time, or like time mean, median, mode. So these are the different features in the data. And at level 1 you can see like the data is to be evaluated based on these machine learning based methods. So in the first you can see that logistic regression model is being implemented, random forest is also implemented, LGBM is to be implemented, and then the final prediction at level 1 is to be done. And then similarly on the second, like we have tested against the decision tree, random forest, and LGBM, right? So there's a set of second level data where the classification is to be done whether the traffic is malicious or non-malicious. And these are the examples of like classification at level 1. And from the level 1, if you'll see like EL1 and EL2, EL1 and EL2 are ensemble approach to identify the door traffic. So these two are like EL1 and EL2 are proposed method, and then we have the conventional machine learning methods. For that also we tested, and the results are analyzed in terms of precision, recall, and app score. And if you will see like EL1 and EL2 results, so no matter whether it's a precision or recall or the app score, the results are better compared to other machine learning based methods that researchers implemented earlier. So the ensemble framework is better in terms of classification or data. And this is the accuracy. So this is also like accuracy is also being testing and tested, and you can see like our model is almost accurate, like producing 99% accuracy, right, at level 2, and while 98 and 99 for like at level 1. So from the results it's being evident like the accuracy is also good when we design and we implemented this ensemble framework. These is a table of false positive and false negative, and from there we can say like the result states and shows that our model is giving the less number of false positive and negatives, right? And if you will see, like, comparatively with the other conventional methods, then naive Bayes makes the maximum misclassifications. Right? That's not a good approach, by the way, those. And the ensemble techniques make less misclassifications, and that's another thing. Like, in terms of error optimization, we optimized, and like, the proposed method gives like less number of misclassifications from the data. This is the conclusion and future work. So two ensemble-based learning techniques, EL1 and EL2, that showed superior and state-of-the-art results in categorizing dot traffic by achieving an overall accuracy of 99.5 and 99.7% respectively, at both the levels, right? And F score is also like 99.8 and 99.7. And these are the results that we achieved on the dataset when we tested this model against the real-time capture dataset. Then the accuracy is around 87 and 92% at both the levels. Why? Because we have we have less number of records, and that is what we made, like different configured different servers, and then we tested again. That was the reason, by the way, and that's complex as well. So the proposed ensemble-based technique requires more computation in terms of analysis, and in terms of analyzing the real-time traffic, by the way. Okay, but due to the accuracy and less misclassification error count on the real-time simulated, makes it ideal for deployment in real-time scenarios in discovering malicious traffic in the network. Okay. So as the thing is that the proposed method gives you less number of misclassifications, and that make it more favorable when it comes to the real-time deployment. And analysis of dot traffic and detection of dot tunnels in mobile devices, that is the future direction, by the way. So in the future, you can think of how these dot tunnels in mobile devices, how you are going to detect that. Another thing is that, like, as a future direction, now this is like DNS over HTTPS, and now we are implementing TLS over HTTPS. So TOP, so that is TOH. So I mean, a TLS over HTTPS, that kind of traffic is also being analyzed and detected. So we are working on that. But as a future direction, if anybody wants to work in that direction, they can do so. And these are some of the references from my presentation. And thanks for listening. So if any of you have any queries, then you can ask me, or you can take my details and you can write to me as well. So these are my details, by the way. So here you can see my email ID, and I think there. If you want any research collaborations, we can go with that as well. So we have a big team in my research cluster that's working on the security based AI based security analysis. They are doing right now. They're also implementing TLS. Thank you again. Once again, thank you very much for listening.
Thank you, sir, for your nice presentation and sharing your email ID. So the user can, the participant can contact you if they have any query or any suggestion in future from this topic. So they can easily connect you. Thank you, sir.
Sure.
Thank you. Yes, our new keynote speaker is Pravishek Singh, sir. So before starting, I would like to introduce sir. Dr. Pravishek Singh is working as an assistant professor in Bennett University since July 2022. He worked as an assistant professor at MIT University, Noida, India for more than 3 years. He did his PhD in 2018 from Baba Saheb Bhimrao Ambedkar University, a Central University, Lucknow, from CDAC Noida. He did his BTech in 2010 from AKTU, Lucknow. Prior to joining MIT University, Uttar Pradesh, Noida, he was associated with Krishna Engineering College, Ghaziabad, and Narayana College of Engineering and Technology, Kanpur, as an assistant professor in CSE department. His research interest includes image processing and computer vision, deep learning, and machine learning. Sir was awarded as a National Fellowship for 2017 during the PhD course. He was also awarded Excellent Researcher and Best Young Scientist by GECL 2021 and GECL 2022 for his outstanding performance, commitment, dedication, and demonstrated significant leadership in said area. He has published 130 plus research papers in journals and conferences. He serves as a senior editor, associate editor, academic editor, reviewer editor, leading guest editor, reviewer in various SCI, Scopus journals and other prestigious conferences. Sir, over to you. Sir, unmute yourself kindly. Yes, sir.
Okay, thank you so much for the introduction and congratulations for the well-going of your conference. I see ICISTECH 2023 and I'm very honored to be the part of to be invited as the keynote speaker in this conference. So today's my session is on raising research profile, cracking editorial board position.
Sir, kindly keep your PPT in presentation mode.
Now is it okay?
Still not.
I think now it is fine.
Okay, sir.
Fine.
Sir, if you face problem, then you can do it. What then unshare your PPT and then again share.
Okay, I'll.
Yes, sir.
Just a minute. Now it's fine.
Sir, your PPT is visible.
Okay. Okay, thank you.
Okay, sir.
Okay, thank you. So I'm Dr. Abhishek Singh. Currently, I'm working as assistant professor in Bennett University. And my topic is that I'm going to discuss today is raising research profile, cracking editorial board position. So there are many ways using which we can enhance, improve our research profile, like publishing high quality, good research papers in high impact factor journals and conferences, achieving good national and international projects, and having patent grants. Apart from that, there are some other domains also which we can conquer, but most of the researchers which we don't opt for these particular domain is editorial board positions, because this is one of the very gray domain which normally which I have seen that researchers are not going for. So the topics that I'm going to discuss is what is editorial board, what are the benefits, objectives, various types of editorial roles, various editorial roles in different publisher journals, what is the process, what are the ethics and responsibilities, benefits of doing the reviews, requirement of the journal to become an editorial board role, how we going to crack the editorial board role, how to apply for it, and when to stop applying. So what is the editorial board role? So editorial board is actually an advisory board, and this board is created by the editor-in-chief. And this board is about the group of the prominent people in the journal's field. Let's say if the journal is of image processing domain, then the editorial board of that particular journal will be of those people who are working in the domain of image processing. So these editorial board act as an ambassador of the journal because they represent the journal, and the quality of the publication being done in that journal is being judged by the editorial board members. So there are a lot of benefits for being editorial board member. First of all, if you become an editorial board member in a very good journal, then you will get connected to a lot of other editorial board members who are reputed and distinguished professors in that said area. Also, if you are an editorial board member, you will get a chance to publish 1 to 2 research papers every year in that journal. You will get a chance to propose a special issues in the journal every year or in 6 months. Possibly there are a lot of possible promotions are also there. If you are an editorial board member, then you can get promoted to associate editor, or if you are associate editor, then you can get promoted to senior editor. In some cases, honorarium is also there, but this is very rare cases are there. What is the main objective of being an editorial board? So identifying new topics for the commission is special editions. So basically here the editorial boards checks for what are the new topics that they have to identify and they have to only publish such new topics so that the citations and the publication quality of that journal should be enhanced and improved. And their objective is to approach good researchers, good scientists, distinguished professors who are working really, really good in their domain. So approaching such potential contributor also is one of the objective of editorial board. They also advise the direction of the journal. They check whether the journal is doing good or not, whether they are making any mistake or not, whether the other editorial members, the juniors, the assistant editors, they are working in a proper way or not, whether the peer review process is going on in a proper way or not. And they also endorse the journal. They are kind of, as I said, they are kind of an ambassador of a journal. So they represent that they promote the journal worldwide. There are various types of editorial roles like EIC, managing editor, senior editor, section editor, specialist editor, associate editor, academic editor, role member, guest editor, assistant editor, language editor, video editor, production editor, copy editor, reviewer. But being a researcher, being a scientist, you have to only apply for these positions like assistant editor, guest editor, editorial board member, academic editor, associate editor, section editor, specialist editor. And when we get very senior, when one researcher have experience of 20 years, 30 in a specific domain, and he did really very good in that particular domain, then he can apply for the senior editor, managing editor, and EIC. So various editorial roles in different publisher journals. So all the different there are editorial roles, and all these roles are being decided by the editor-in-chief. It is not being pre-decided that all the journals will have the same roles. It completely depends upon the editor-in-chief whether what roles he are going to decide. For example, if I take example of biomedical signal processing, Elsevier journal, there are 3 editorial roles: EIC, associate editors, and editorial advisory board. If I talk about JEI SPY journal, then it is EIC, senior editors, and associate editors. There is a RTIP, stranger editor-in-chief is the advisory board editorial. Similarly, you can see for BMC medical imaging, there is editor, there is assistant editor, there are senior editorial board members and editorial board members. Similarly, for other journals also, there are different roles. And all these roles are being decided by the editor-in-chief. So what basically is the editorial process? So all these people in a journal, if there is editorial board member, EICs, their senior editors, their associate editors, what they're actually doing over there. So whenever we submit any research paper in a journal, that research paper is being received by the editor-in-chief. Editor-in-chief sends that research paper to the senior editor, and that research paper is being assigned to senior editor. Senior editor perform the initial assessment, and he checks the quality, whether he's going to straight away reject it, or he will assign, if he finds the paper suitable, then he will assign that research paper to the associate editor. Then associate editor also performs the initial assessment on that particular research paper. And if he finds the paper okay, then he will assign the reviewers. If he don't find the paper okay, then he will straight away reject it. And if he finds okay, then he will assign the reviewers. Then review process will go on. And when the reviewers will submit the report to the associate editor takes its own decision, major, minor revision. And after that, associate editor submits that decision to the senior editor, and then senior editor reviews the decisions being taken by the associate editor, and he sends the decision to the authors. So whenever we see that sometimes our paper get rejected in the journal, desk rejection is there. So desk rejection, EIC never does any desk rejection. So desk rejection, EIC always gives the research paper to senior members of the journal. So rejection is being done by the senior editors, not by the EICs. So what are the ethics and responsibilities of the editorial board member? This is one of the most important slide as to understand the ethics and responsibility. First of all, conflict of interest. Whenever as editorial board member you are handling any research paper, then you have to check the conflict of interest. If you found and check, my slides are not moving. Hello, ma'am, my slides are not moving, please.
And now it's moving, sir.
Okay, now it's moving.
Yes, sir.
Okay. So as I said that we have to check for the conflict of interest. So if you are handling any research paper of your own co-authors, that you cannot handle it. So you have to take care of the conflict of interest. So reviewer assignment is also very important. You have to take care of reviewer assignment. You have to treat all the authors with fairness, objectivity, transparency, and honesty. And you have to take care of the confidentiality of the author's work. Means if being editorial board member, being a senior editor, being associate editor, you cannot copy the idea of the authors. It is totally protected when the work is being submitted in the journal. Apart from that, editorial board member also handles and checks how the peer review process is being going on, whether the peer review process is going on in time, whether the peer review process is okay, whether it should be within the time, and all the comments being given by the reviewer should be critical, and there should be no self-citation. Being editorial board member, whenever you are handling any research paper, make sure that you are not doing any kind of self-citation. There should be no self-interest when you are an editorial board member. So next slide is about benefits of doing reviews of an article. Ma'am, can you see this slide? Slide is moving okay? Okay. Okay. So benefits of doing the reviews of an article. So the benefit is this, that whenever we get any research paper and we have to review that particular research paper, we make sure that we are reviewing that paper, because from the associate or editorial board point of view, that reviewer is being given ranking. And this ranking is being given based on the critical comments, timeliness, and the quantity of reviews being done by that reviewer in that particular year. You can see in the slide, the reviewer, he will be give ranked excellent, good, satisfactory, marginal, poor. So based on this ranking, you can see this kind of database is being created in the journals, in the journal, and this database of ranking of reviewers is very important, because the top rankers reviewers sometimes get the chance to become the editorial board member. Requirement of the journal for the editorial board's role position. So there are three different things. That firstly, what is the driving factor? Sometimes there is a demand of additional or the replacement of any editorial role in a particular specialty area. Sometimes we can also refer colleagues for, let's say there is one of authors or one of friends is associate editor or senior editor in a journal. Then he can refer to us. That if he refers to us to be the part of the editorial board member, then that EIC will take care of his request, and there is a high probability of becoming the editorial board member. Sometimes search is being conducted by the editorial office of a journal, and sometimes self-recommendation is there. In most of the cases, you can see in 95% of the cases, self-recommendation works, because being a researcher, being a scientist, being a professor in the domain, it is your responsibility to apply for all these positions. The search conducted by the editorial office and the replacement of all these roles are very rare cases. What are the factors that will that journal considers? So as I said, why reviewing the paper is very important, because based on the review, they make a ranking of all the reviewers, and the top ranker reviewer get the chance to become the editorial board member. So this is very important. Editorial office, EICs give preference to the top reviewers. Second is high education. The people who are having PhD postdocs, they are preferred for the editorial board positions. You should be having good citations in Google Scholar, Scopus, and other indices. Academic ranking equivalent to higher position of professors. So the professor ranks people, they get the higher chance to apply for the senior ranks like senior editors and EICs. But being a new researcher, being a fresh researcher, you can apply for the fresh positions like editorial board member or assistant editor or guest editor or associate editor. So diversity consideration is also very much important, because the journal also wants that their editors should be from different part of the world. Educational background is also very important, because they see that what experience their editors are having, and they prefer the people who are working in USA, Canada, Europe, and all these countries. So how to crack any editorial board role of any journal. So this slide is about how, now we will talk about how we can crack an editorial board role. So first of all, you should have enough research papers in your profile. As I said, there can be 15 to 25 research papers. This is just a number. I will not say if exactly this much number is required, but you must be having 15 to 25 research papers in your profile. The visibility should be very much clear of your area of interest. And these 50 to 25 research papers can be a journal paper, conference paper, but they must be a high quality research paper. And make sure in the last 5 years, you should be publishing research papers with first author or as a corresponding author. This is the first requirement which you have to do if you want to crack the editorial board role. Second is your H index. It is very mandatory that you should be having a very good H index. 2-digit H index is very much important if you want to crack editorial board role, because it says that you are performing good, your papers are getting good citations, and this H index should be as per Scopus database. When you are calculating your H index, make sure there should be no self citations. All the citations should be organic. Your H index should be organic. And the way to increase the H index is better to encourage your fellow researchers, your co-authors, to read and cite your research paper. So you have to target the journal. So which journal I want to become editorial board role. So you have to select and shortlist only those journals which belong to your area of interest. Journal theme journals are also taught. For example, I'm working in the field of medical imaging. So medical imaging is a part of the computer. So if there is a journal who is working on the journal theme, then I can also apply for the editorial board role for the journal theme journals. Also, I should also prefer to give prioritize to those journals who are publishing research papers in the field of the medical journey to my area of research. Before applying for editorial board role, you have to read the aim and scope also. Your profile should demonstrate expertise that fits within the scope and the need of the journal. Because if you apply out of the scope of your area of interest, that journal is not going to entertain you. Next is which journal to target. You have to target very intelligently. Smart approach is required. You have to check your research profile. You have to analyze yourself. And based on your analysis, you have to apply for the editorial board positions. For example, I have cracked 20 research papers. Out of these 20 research papers, I have 5 SCIs. And the maximum impact factor of my research paper is 5. So I have to apply for the editorial board role to those journals whose impact factor is less than 5. And I should be applying for those journals who are Scopus index. I shouldn't be applying for those journals whose impact factor is 30, 40, 50 or transaction level journals. You should be, so that means that the application for the editorial board role should be very intelligent. You have to check your research profile, you have to analyze yourself, and based on that analysis, you have to do the application. For your application, few things are very important. First of all, your CV should be very impressive. You have to create your professional web page. These days, web page creation is not that difficult. You can use Google site to create the professional web page. Then institutional web page is very much important, because whenever any editorial board member is checking your profile, he is checking whether you're working in that particular organization or not. So institutional web page is mandatory. Create and mention a Google Scholar profile, Scopus profile, Web of Science profile, ORCID profile. Make sure all these profiles must be in your signature. So application which you are writing to the editor-in-chief or any managing editor of that journal, it should be an enthusiastic application. Give emphasis on the successful completed research assignments which you have done. So how to write an application, how to write an email. So first of all, your subject should be like this. You have to apply for the post of editorial board name. So for example, you are applying for the associate editor. So you have to write applying for the post of associate editor. Dear editor-in-chief, this is to whomever you want to address. For example, you want to address editor-in-chief or managing editor or whoever, editorial office. So you have to address him, you have to write the journal name. So basically there are 3 paragraphs. First paragraph, you have to make sure that what you are applying for and why you are applying for. This is very important. And you have to write this thing in 3 to 4 lines. Okay, what to apply for and why you are applying for. For example, I'm applying for associate editor, and why I'm applying, because I have already working as a editorial board member, guest editor, assistant editor. I have a great experience. I have worked on these particular roles in last 2-3 years. So I'm desperate to work on this particular role. So this is what you have to write in your first paragraph. Second paragraph is very important. It will tell you about your qualification, about your leadership role, what you have done, what you have not done, what you have successfully accomplished. Third paragraph is also very important. It will tell, you have to tell about your additional skills, what motivates you, what exactly is your motivation. Then finally you have to thank him for their time and consideration. Plus, but please make sure the editor in chiefs and all these people at the higher posts in the journals, they are very busy. So your signature is very much important. This last signature is very much important, because in this signature, make sure you must be highlighting your professional web page, institutional web page. You have your Google Scholar profile, Scopus profile, Web of Science profile, ORCID profile, your email ID, your phone number. And when to stop applying. After, let's say you have applied for 10 places and you get approval for 3 to 4 journals, you got an approval of editorial board role, then make sure you should stop at that time. Because being editorial board member, it's kind of a very tedious task, because you have to handle a lot of papers and you are not getting all the time an honorarium for all these roles. So applying for working for 3 to 4 journals as an editorial board member, I think is sufficient. Because I must not use that word, but it is kind of a thankless job. It is not actually a thankless job, but it is kind of a responsibility. But since we are not being paid for this work, so stop there when you are having 3 to 4 approvals, and work with all ethics and responsibility when you are working as editorial board member. So if you have any query, then you can please ask me, and these are my email IDs if you want to get connected, so we can connect on this.
Thank you, Pravishek sir, for your nice presentation, and thank you for accepting our invitation. Thank you, sir.
Thank you.
Yes, dear participant, our new next presenter is, the paper ID is D46. Dr. Sanjay Kumar. Sir. लाइट जला दीजिए, थोड़ा इनके फेस पे कलर आए।
Dear participants, there is some technical problem. So in place of Dr. Sanjay Singh, Dr. Pratish Ranjan will present his paper. The paper number is D66. Dr. Pratish Ranjan, please. ये है आपका खुला हुआ है स्क्रीन से है ना स्क्रीन तो है हाँ तो स्क्रीन शेयर स्लाइड करेंगे तब नहीं तो नहीं प्रेजेंट करेंगे ना सर शेयर स्क्रीन शेयर नाउ नहीं सर ठीक है ठीक है इस सेशन को ना इनको नेक्स्ट आप मैं अपने लैपटॉप से करता हूँ अब मेरा मीट खुला हुआ है इसी
Hello. Hello, can you hear me?
निकाल दिया सर आपने यहाँ से अरे अब आएगा
So my topic for, first of all, good evening everyone. My topic for the presentation is a control exploration of vulnerability assessment and penetration testing through Brupsuit. So let me delve into the topic. First of all, vulnerability. Vulnerability implies the loopholes in the entire network structure. It starts from the application and it ends with the network infrastructure. So my paper deals with the vulnerability in entire network structure, but we will be concentrating on the vulnerability on web application, and this vulnerability is being tested using Brupsuit. So Brupsuit is a collection of so many tools which tries to analyze the vulnerability of the web application, and it mainly analyze brute force attack, SQL injection, and cross-site scripting. So first, what does the Brupsuit does? First of all, it intercepts the traffic. So there are a lot many information when we try to intercept. First is, you can see at the image, first image is get API 4963.387 HTTP 1.1. It tells the get method is being used, and this and API 4963387 is the application ID through which is being fetched through get method. And the host is, next is host, that is bsefci.bihar.gov in. We are trying to penetrate into the web application whose domain name is bsefci bihar government.in. So we're trying to penetrate into the government website which belongs to a government of Bihar. Next is SECCHEUA, not a BI and V version, and Chromium. It tells what kind of browser is being used to access that website. Next is SECCHUA mobile. That is question mark 0. It tells that this website is not being accessed by the mobile application. Next stage, SECCHUA platform Linux, means the server on which this website is being hosted is Linux, and the user is also using a Linux platform to access that website. So lot many initial information we can get through the interception of the traffic through Brupsuit. Now, in Brupsuit, there are different kinds of attacks which is being available through which we can do the attacks. Here we have used sniper attacks. Okay, there are many other attacks such as Brinch Flit, Ram Bapper, all kind of different attacks are available. But in this, we have tried lot many attacks, but sniper attack was very much successful in this website. So we started the sniper attack. Now, when we started the sniper attack, the information which we get here is, you can see we are using the get method, the host, the Chromium browser, the mobile it is not being accessed through the mobile, the Linux operating system is being used by the client. So you can get all those relevant information related to this website. Okay, so lot many you can check fetch destination and accept encoding gz flat, lot many initial information is there through which we can get. Now, when the access is being done to this website, or we try to penetrate into the website, we need to set the payloads. Payloads means if the parameter is being passed through the payloads, because when we access the two method, whether it is a get or the post method, the parameter need to be passed. Okay, so here we need to select the what kind of parameter you are passing. So you can see here the payload open optimum number. Okay, you need to set the payload optimum number to attack that particular website. Okay, and when you set it is a random number, and you need to have some critical thinking about the payloads, where you access the user and name and password through the payloads. And when you set the payload, somehow you can see the entire information of the employee of that organization. You can see when we set the payload number is this, and you can see the employee Aadhaar number, employee email ID, and employee username, and employee password, and lot many information. All the proprietary information of the organization is being accessed. So you can see the usefulness of this tool, Brubsuit, which can be easily configured, and the website could be analyzed through this website, and you can get the very personalized information through this easily or simple tool that is called Brubsuit. So no, this information is so critical, because this kind of information could be used for the phishing or the spamming, and the critical information of any person can be disclosed. So there are many organizations who runs their website, but they have never been penetrated. So in my point of view, if there is any website, if you have a website, you think who will attack my website, or why will it be attacked? But it is never that case. If attacker is not attacking your website, it is not that they can take the benefits from other side also. You can be act as a pivot, or you can act as your website could be act as a pivot, and the attack could be launched through your website. And ransomware is the most famous attack through which the website is being defamed, and the ransom is being asked. And all the financial organization and the hospitals, they all feel ransomware attacks were quite frequent during the COVID-19 pandemic. So so if any, for the developer point of view, if you're developing any kind of website, they must go for the Brubsuit analysis, so that they could find the minimum information about the information. So this was all about my presentation. If anyone having any query, just let me know. Thank you.
Thank you, Dr. Pritish Ranjan, for a very wonderful talk. Uh, Audience, if someone has any query, you may write your questions in the chat box. And we are moving for the next speaker, Dr. Sanjay. And okay, our next speaker is Dr. Sanjay Kumar. So he will be presenting offline from here. Dr. Sanjay, please. आइए हो रहा है सर Okay. So Dr. Sanjay, please come. Screen share. Slides. Screen shared already. Okay. Anyway.
Hello, my slide is visible. Okay, okay. So first of all, good afternoon, everyone. And my presentation topic is QoS analysis in lowest dimensional fractional order satellite system and its control technique. I am Sanjay Kumar, assistant professor, Amity University, Patna. And my co-author is Ram Pravesh, Mahendpal, Kishan Pal, Ajit Singh, and Vishal Srivastavs. And these are their associations with different universities. So outline of my presentation is introduction to QoS, fractal order derivatives, and QoS measurement and QoS control. So everyone familiar with QoS because this inverse is nonlinear and QoS is the part of nonlinears. So we try to understand that what is QoS. So QoS is nothing but a bonded a periodic which is highly sensitive to initial condition. Bonded means ki there bonded periodic means there is phase portrait should be bonded. Aperiodic means which is not periodic. Highly sensitive to initial conditions means wherever we slightly change the initial condition, trajectory will be very drastic change in its positions. So QoS is highly it is deterministic because whenever fixed value of parameters QoS exists, we change the parameters, QoS does not exist or may not exist. So this is the beauty of QoS. So or QoS exist in non-linear dynamical systems. So these are the abstract of our papers. So I'm not reading all these things. Only we are stating that we are talking about a satellite system, and there is a stability, not a stability system is stable or not. Their measurement key, which positions, what is the tools for where system is QoS does not QoS with different different orders of dynamical systems. Okay, so these are the brief introductions, basic introductions of what is a fractional, because everyone familiar with derivatives. So derivatives nothing but the rate of change of the systems which is evolved with times, and this is the fractional order derivatives nothing but we try to change the integer order dynamical system to fractional, or because whenever we are talking about derivatives, so we are approximating the system. We are not a precise way we define the non-linear disk systems. So we try to precise our values in this evolving dynamic systems. So these are the one of the way for studying the dynamical systems. And fractional order is one of the best tools for more accurate precising the systems. So these are the formula number 3 is one of the best dynamical system. Fractional or dynamical system converted to first of all gamma beta functions through integration sign. These are the basic formula for converting dynamical system into fractional dynamical systems. And these are the three-dimensional satellite system. These are very precise way of writing in a vector form of dynamical systems. Behind there's a lot of equations of converting into a vector order dynamical systems, or these are the phase portrait where we are taking the initial conditions of dynamical systems in a 3.5 0.5 and 0.8. These are the XYZ axis. This is the state variables of the three-dimensional satellite systems are the corresponding these are the fractional order satellite systems, and ABC are taken as parameters, and these parameters value are 0.4, for A, B is equal to 0.75, and C is equal to 0.45. These are the parameters values, and these are the phase rate for a different parameters value, and we try to try to predict that which systems for which value system is stable or not. So we have taken as a different orders. Suppose that we take as a 0.91, that is the fractional part of a fractional order of the systems. So in this way, system is stable in the sense, whenever we are the mathematicians, so we are trying to minimize precise the system mathematically. Basically, system is stable or not stable in the sense ki, first of all, we non-linear system to linearize, and first of all we find the equilibrium point in the sense ki we trying to whereas all trajectory meet yani ki solutions point is said to be equilibrium points. So linearize through a Jacobian method, we linearize the nonlinear system to linearize the system, simple sir. And we find the eigenvalues. Through eigenvalues, we say that the system is stable or not. If eigenvalues, real part of real part of eigenvalues are negative, then system is said to be stable. And if as a real part of eigenvalues are positive, then that is said to be unstable systems. The stable system in the sense ki phase, that means ki phase portrait of the system converge, and unstable in the sense ki phase portrait of the system is diverge in a general terms. So stable means ki we are try to predict their behavior natures. And periodic in the sense ki system is periodic, that means ki real part of the system is zero only, they have an imaginary part. Eigenvalue of dynamical system is have negative, real part is zero only as an imaginary part, then it is periodic in the sense after a certain interval they repeat their patterns. And quasi periodic means ki after certain they have irregular behavior, and some repeat this, that is the chaotic. And through as a phase portrait, time series graph, and 3D as a 3D phase portrait of dynamical systems, satellite dynamical system is showing. So you can analyze, but we can zoom, then you will realize that which system is chaotic or not. Only a system is figure number one is A is stable, because you observe that after a certain they are converging to one points, so it is a stables. And it is shown in the different component wise, x y z components wise. So through this figure analysis, you can easily observe that which are stable, which are not stable. So that means ki J, H, K, L, last 3 and 4 are unstable chaotic systems. There are another, this is the phase measurement, through that we are saying that the system is stable or not stable. These are the some parameters value there. We are observing that the system is chaotic or not chaotic, which are periodic, which are not periodic. And there are another tools for measuring the chaos is Lupnov exponent. Lupnov exponent, one of the best tools for measuring that. If one of the Lupnov exponent is positive, then it is said to be as a chaotic system. At least in whenever we talking about as a three-dimensional, as a continuous dynamical system, we are presenting in the three-dimensional continuous systems. So one Lupnov exponent must be positive, then it is said to be chaotic. Otherwise, no. If as a three-dimensional, we have as a corresponding 3 as a Lupnov exponent, all are negative, then it is said to be as a stable, not as a chaotic. If at least one is must be positive for as a chaotic systems. And the other is bifurcations method. Bifurcation is one of the best tools for representing the chaoticity, measurement of chaoticity of a dynamical systems. Whenever we changing the previous we are talking about ki system is as a chaotic or not through as a deterministic value. That means ki fixed parameter value. When we are changing the parameters value as a, for a certain as a parameter certain intervals, then we are saying that ki there a trajectory breakup. That means ki that means bifurcations, literally it means as a breaking into two and more than two parts. So we are assuming this as a they are trajectory breaking that, not moving in a single as a line, two lines or three lines. It is as a breaking as a in a different phases. So it represents that our system is too much chaotic. There is one of the tools whereas we have taken as a different as a parameters. We have taken A, B, C, where we are taken in interval form, and then as a there are a lot of as a coding behind that for as a plotting this graph, and these are the representation of as a bifurcation of a bifurcation of satellite systems. And last figure is our as a controlling of as a satellite system at as a t is equal to 30. This is a more precise way for as a controlling the chaotic dynamical systems through as a feedback gain. And these are conclusion. There applicate lot of applications in real life for telecommunications, secure telecommunications, data security, radar detections, weather forecasting, GPS system, earth observation. These are the well-known applications of a satellite system, and we are more familiar with that. Without that, we are not too much precise about communications. And these are my references, and in which we have more than three and four research paper which is published in SCI journals in satellite systems. And last is questions hours. And thank you so much. Thank you so much.
Thank you, Dr. Sanjay. Your presentation was very nice, and all slides was full of mathematics. So, and the result that you have prepared by using some tools. So, nice presentation, nice slide, and really a great presentation. Thank you, sir. Now, dear participants, the time come to conclude this conference. So, I'm going to summarize this conference. Ladies and gentlemen, esteemed faculty members, and dear participants, it is with great pleasure and excitement that I stand before you today to present a comprehensive summary of International Conference on Innovative Science, Engineering, and Technology, ICISTECH, held on the 7th and 8th December 2023, unfolded under the overarching theme of advanced sustainability and resolution through innovation. Dr. Vivekanand Pandey, the Honorable Vice Chancellor of Amity University, Patna, warmly welcomed the distinguished guests and participants. The event commenced with the chief guest, Professor Dr. K.C. Sinha, Honorable Vice Chancellor of Patna University, gracing the occasion and inaugurating the conference with a lamp lighting ceremony, followed by the sacred Ganesh Vandana. Professor Sinha emphasized that technology acts as a toolkit for mathematics. The chief guest also urged faculty members to incorporate real-life examples into their lectures. Honorable Vice Chancellor, Amity University, Patna, acknowledging the chief guest's presence amidst a busy schedule, highlighted the pivotal role of technology in financial growth of the country. He underscored how technological advancements could lead to increased exports of defense equipment. Dr. Shashi Bhushan, Director, Amity School of Engineering and Technology Asset, provided insights into the conference theme and articulated how this gathering would be instrumental for faculty and researchers. With the substantial submission of over 70 papers from India and abroad, a meticulous selection process resulted in the acceptance of 32 papers. These selected papers are accepted for publication in the prestigious Scopus Indexed Conference proceedings published by Springer. Across these 2 days, 2 tracks and your daily sessions were conducted. Morning session of first day featured keynote speakers and sessions chaired by distinguished professionals, notable personalities such as Professor Dr. Anchit Bizalwan, British University, Vietnam. Dr. Aditi Sharma, she is the visiting faculty at Astana IT University, Kazakhstan, and University of UO, Nigeria. Designated as Associate Professor at Symbiosis Institute of Technology, Symbiosis International University, Pune. And Professor Rasmi Bhardwaj, Professor Guru Gobind Singh, Indraprasth University, New Delhi. And Dr. Manoj Divakar contributed insights, perspectives. The second day mirrored the pattern with a morning session led by Dr. Jonathan Mishnayot from South Africa, Dr. Kumar Pallav, Associate Professor, Cape Peninsula, University of Technology, Cape Town, South Africa, and Dr. Narsingh Jha, Assistant Professor, IIT Delhi. While evening sessions were enriched by the expertise of Dr. Manoj Kumar, Associate Professor, Wollongong in Dubai, UAE, Dr. Rajiv Srivastava from IIT BHU, and Dr. Pravishek Singh, Bennett University. The vote of thanks at the conference was eloquently delivered by Dr. Saurav Sambhav, the conference convener. The organizational efforts were spearheaded by Dr. Saurav Sambhav, Dr. Vishal Srivastava, and co-conveners Dr. Shilpi Singh and Dr. Lalita Kumari, all making significant contributions under the aegis of MIT School of Engineering and Technology. Ladies and gentlemen, esteemed faculty members, and dear participants, this successful event was made possible by the collaborative teamwork of MIT School of Engineering and Technology. As we conclude this enlightening conference, I extend my heartfelt gratitude to our Honorable Chief Guest, Professor K.C. Sinha, Vice Chancellor of Patna University, for gracing us with his profound insights and scholarly presence. His contributions have significantly enriched our event. I would also like to express sincere appreciation to our chief patrons, Honorable Dr. Ashok K. Chauhan, Founder President of MIT Education Group, and Honorable Dr. Atul Chauhan, Chancellor of MIT University, for their continuous support and vision. Our patrons, Mr. U. Ramachandran, Senior Vice President of MIT Education Group, and Mr. Gaurav Gupta, Vice President of MIT Education Group. A sincere thanks to Dr. Vivekanand Pandey, Honorable Vice Chancellor of MIT University, Patna, Dr. Shashi Bhushan, Director of Asset, Dr. Navneet Kumar Yadav, Deputy Registrar, and Dr. Sushil Kumar, Deputy Controller of Examination, Assistant Director, MIT University, Patna, for their instrumental roles. To our esteemed faculty members, national and international participants, dear students, and everyone present here, your active participation has truly made this conference success. A special note of appreciation to our ESCO department, admin, our IT team, teaching and unteaching staff, volunteers, and students who work tirelessly behind the scenes. Our collective efforts have made this conference a hub of inspiration, collaboration, and knowledge exchange. In closing, as we bid adieu to this successful conference, let us anticipate the promise of future engagements. We look forward to welcoming you again next year for another enriching and inspiring edition. Thank you all. Thank you. Thank you. Highly appreciate. Dear all, you can leave the session. Thank you.